It is today more vital than ever that we have long and reliable historical records of the Earth's climate. Thanks to the abundance of modern observation methods, our weather records for the present are quite complete. The problem is, these observations are not evenly distributed around the globe, and there are also fewer and fewer of them as we go back in time. Climate reanalysis can solve this problem. It combines observations made in the past with today's weather model to deliver a complete and consistent picture of the past weather. Imagine the weather of the past as a series of jigsaw puzzles with pieces missing in some places and overlapping in others. The pieces we have are observations coming from weather stations, weather balloons, aircraft, ships, satellites, and other sources. The reanalysis is like a smart machine that uses the weather model to combine and process all the information from those pieces. Using the laws of physics, it is able to blend overlapping pieces and recreate pieces that are missing in a consistent way, thus restoring the complete puzzle. The reanalysis delivers a global picture of the weather and climate of the past as close to reality as possible for each and every hour, from the Earth's surface to the top of the atmosphere. The data produced by the reanalysis are widely used and provide many kinds of information, not only about the atmosphere, such as temperature, wind, and precipitation, but also about the ocean and the land surface. As such, reanalysis represents a comprehensive historical record of the Earth's climate and provides an accurate way to monitor how fast it is changing.
Temperatures are rising, and with them, the land and the ocean become warmer. Dry soil gets drier. Ice melts faster, and the sea level rises. The Earth's climate is a complex system with many interacting elements. To form a coherent, trustworthy picture of its state, we need regular measurements of the atmosphere, oceans, and land. That is why the essential climate variables, or ECVs, were identified. A set of 54 key climate components to be measured and monitored to understand different aspects of the climate system, how it is changing, and the best way to adapt. The Copernicus Climate Change Service, or C3S, provides the most comprehensive data collection of essential climate variables in a single platform. From the past, thanks to the extensive archive data available, it is possible to recreate long records of ECVs. To the present, the cutting-edge and quality-assured data from these variables is essential to understand the current state of the climate system and the changes happening. Into the future, ECV's data can help improve model predictions and guide decisions on the best way to adapt to the effects of climate change. The number of essential climate variables available in C3S will keep growing as science and technology develop, adding to its expanding set of climate products and tools that combine satellite data, in-situ measurements, modelled and rescue data, and reanalysis across air, land, and ocean. The Copernicus Climate Change Service is the one-stop solution for your climate monitoring needs. Access our climate data store and find the data you need to make smarter decisions. Where is the best place to build a wind farm? Could changes in rainfall cause flooding in my region? How will trends in sea ice impact shipping routes? To find the answers to these questions, you need climate data. But just as not all tools are appropriate for every task, Not all datasets will suit every need. Do you need long-term records to understand trends? Or shorter-term records for details of the current situation? Data for a specific location or an overview of a larger region? After considering questions like these, you also need to take into account other limitations of individual datasets. So how do you know you have the right data for you? The Copernicus Climate Change Service, or C3S, has created a user journey to help you. It starts with a detailed account of each dataset's strengths and weaknesses. When you look in the Climate Data Store, for each dataset you can find answers to questions like: how were the data produced? Are uncertainties in the data documented? Is there a user guide? If you are still not sure you have chosen the right dataset, you can visit the Knowledge Base, a collection of articles checked by experts that acts as a user manual. And if the Knowledge Base does not answer all your questions, you can learn from the experience of other data users in the forum. At the end of your journey, if there is anything left unclear, contact the Support Help Desk, and they will help you navigate any final hurdles. You can find answers every step of the way to make an informed choice about the data that best fit your needs.
Good afternoon to our virtual audience and our fabulous speakers. A very, very warm welcome to day 2 of this epic 3-day event. Yes, it's the C3S Conference and General Assembly organised by Copernicus Climate Change Service with the support of the Italian Copernicus National User Forum. This is the final C3S General Assembly of its phase before a new contribution agreement, and we know one is going to be signed by ECMWF with the European Commission. In case you weren't with us yesterday, my name is Katrina Sickle. I'm a moderator and sometime broadcaster, and I have the privilege of guiding you all through this 3-day extravaganza from the privacy of my home office in Brussels. Now, what I'd like to start with first, because I don't know who was with us yesterday and who wasn't, and you're a very, very broad audience with all sorts of interests and levels of knowledge. You might not have dropped in yesterday. I'd like to just look at a few highlights. Now, I think our delightful technical crew have put together something quite rapidly for you, for which I need my glasses, but thankfully, I also have some of those highlights in my script. Now, we had 1,177 active users out of around 1,500 that registered. That's about 75%, which is absolutely staggering and certainly a record for any event thus far I have moderated online. So thank you so much for those joining us for the first time, or again, don't forget you can tweet at any time, hashtag C3S21. You were also very active yesterday, all sorts of discussions, more than 150, more than 300 contacts made, more than 850 messages exchanged, all sorts of meetings, more than 30 that were created. The one thing that we would like to ask you is make good use of the marketplace. This is a really intuitive platform. It's a fabulous one. And the organisers and the technical crew have done their best to make you catch up on all that networking that you haven't been able to do for the last year and you're not able to do at this event. So do have a browse around the marketplace. It's very important that you shape this event to meet your needs. Now, I'm going to talk in a minute about how you can interact with your questions through the chat function, which you can access if you go into the agenda and click on the session in which we are in. It's very, very intuitive, but I just want to give you a quick recap because yesterday in our opening, we really did explore and unpack a little bit the success story thus far that is C3S Climate Data Service. And we talked about that delivery of timely, of open, of transparent, of quality data that can provide, as one speaker said, a continuous MRI of our planet. And that's just the tip of the iceberg, because actually what we heard is that 3CS is so much more than just a mechanism for delivering data. It also has very quality operational services, standardization, quality assurance, customizing data, training, all sorts of support to the plethora of very diverse users that plug into its offerings. We also learned from the Commission the collaboration thankfully will continue. And we heard some good asks there, some good comments from representatives of NASA and the IPCC. Most importantly, the necessity of centralizing data, sharing it, harmonizing it, and shaking hands across silos. That came out very, very clearly. And also in our second session of yesterday, climate impact and assessment. If you want to catch up on those sessions, all you need to do is go to the C3S website. You can even stick on this platform and you will find links to the recordings of yesterday's sessions. And you can also find an evaluation form. Just think about that, because C3S needs your feedback to shape future events, and you can find all sorts of other goodies online. Now, today, what have we got on the agenda? First off, we're going to talk about climate extremes, and then after a break of half an hour, a poster session in which you can meet your peers online and also look at some fabulous materials and interact with C3S staff. We're going to close with a second 90-minute session dedicated to climate resilience. So that's a very, very packed agenda that we have today. Don't forget, you can ask questions at any time in the chat and C3S staff will try and answer those. but specific questions for our speakers can be asked also. You can see that, and polls that I'll ask you to take part in. Both of those things are accessible in the same place. So we really want you to make your voices heard. And on top of that, some of you kindly sent in questions for speakers as the organisers had requested before the event. And I will pose a select few of those to speakers too in each of the sessions. Now, what are we going to talk about first this morning? Let's have a look at the starting point for our discussion. Flooding, heat waves, intense storms, everything we talked about yesterday have the potential to cause significant damage to people, to infrastructure and to the environment. So we are going to look at how C3S contributes to support disaster risk reduction policies and all the associated climate change adaptation strategies, whether that means characterising the extremes or using hazard assessments to manage associated risk, all of those different pieces of information, and also where perhaps they can evolve their services to better suit their diverse users. Now, before we meet our fabulous speakers, who I'll show you in a slide, but not quite yet, let's please, let me ask you to take part in a poll to check that you're with me, to check that you're awake and alive, and to check that you have accessed the chat. So that's very, very critical. Don't forget agenda, click on this event, look at the discussion tab there, and you can see how it's all laid out very, very simply. So which extreme events should be a priority for C3S? Let's start with that. Which extreme events? Snow, ice and hail, wind, coastal, oceanic, wet and dry, or hot and cold? Which extreme events? If you can take a moment, there is a short lag between the audience on Swapcard and me with my speakers backstage on Zoom. So I'm just going to give you a little bit more time. Yeah, we've already got some results come in. So the majority of people are saying that the extreme events that should be a priority is wet and dry, 44%. Hot and cold comes second on 27%, followed by coastal, oceanic. So there we go. That's where we are. Doubtless that might shift as we go along, but let's see. And the most important people who can have a say on that are, of course, the speakers. So if I can kindly ask our delightful technical crew to put up the nameplate, and then you can have a good idea, take a moment to see who our keynote speaker is, who we will hear from in just a moment, and our 5 other fabulous speakers who will present to you individually, and then who I'll invite back at the end to pose some of my questions, but also some of yours. So we can remove that speaker slide, and I'm going to crack on straight away so that I don't eat into the time of the experts. We're going to now get your brain stimulated with our first keynote speaker. He is a senior scientist and lecturer at ETH Zurich, the Swiss Federal Institute of Technology. His name is Erich Fischer, and there he is. Oh, he's looking very serious and ready. Oh my goodness, you look like you are so clued up. Look at you, neutral background. You've got the headset. You are ready to go. Tell me, I know that you really are going to shape the way ahead also for some of the other speakers in this session. So tell me, what are you going to focus on in a nutshell, Erich?
Good afternoon, Katrina. Yeah, I'm going to address the question, what are the extremes that we should expect to see in the coming decade, and how can we basically assess this?
Fabulous. So I need to give you a chance to share your screen so that you can operate your slides yourself. And I'm going to give you the okay when I can see them. There we go. We'll just hold a minute. Perfect. So I'm going to just pop off for about 8 minutes. And if you can keep an eye on the time, and I look forward very much to hearing what you're going to say, and I'll pop back at the end. Thank you very much. The floor is yours to break the ice for us today.
Thank you very much. Good afternoon, ladies and gentlemen. It's a great pleasure to start this session on climate extremes, which I do see as a challenge to science and society. And this is also a big opportunity for C3S, because C3S is really at the nexus between stakeholders, the science and society. Recent months and years and decades have shown us what happens if unexpected things happen. And when I mentioned the tsunami 2004, we knew that these events could be potentially happening, but it hasn't happened for a very long time in Southeast Asia. And I think this is one of the reasons why people were not prepared, why the devastation was so large. Another event is the SARS-CoV-2 pandemic, which still hits us over the last few months. And again, we knew that these events could happen. It was top risk in the World Economic Forum risk list. Nevertheless, it struck us harder than probably most of us expected. And I want to address the question, are we prepared for the climate extremes of the coming decade? And how can we basically address this question? So observations are a very good start. Ideally, we have very long observation, because what we want to look at is extremes that occur only every 50 or every 100 years on average. So this figure is showing us an annual one-day maximum precipitation over one station that reaches relatively far back. Already shows us that we have variations. We have decades with no intense event, and then a clustering of some other events. It also suggests that there may potentially be a trend. So you can see that this is ideal if you have long observational periods. But if we look at the whole map of changes, we do see that there's more green than brown, indicating there are more places on Earth which have seen an intensification of annual maximum precipitation than reduction. But if I show this to a public audience, most of this, what they see is gray and white, which implies missing data. It looks worse than a Swiss cheese. And I can say this as a Swiss person, there's more holes than cheese, there's more gaps than observations. So while C3S is already doing a fantastic job in giving access to observational data, there's still a long way to go. What are the reasons for these gaps? So first of all, in some places, we simply don't have the observations. In others, they only exist on paper and need to be digitized. Ed Hawkins is going to talk about this. And number three, and this can be sometimes a bit frustrating, is that the data exists, but is not publicly accessible. And I understand very well that there are obstacles, it's administrative, it's challenging, there's taxpayers' money that goes into this data. There's a strong need really to make all this data that is available anywhere, to make it available to science and stakeholders, because really we need it to understand what we should expect from the coming decades. So what is it that we should be expect? If climate behaves like long jumping, we should not be worried. What you see here is Bob Beamon. Bob Beamon set the world record in long jumping in the year 68. And then it has never been broken until 91. And when it was only broken by a very, very small margin. And ever since this last 30 years, it's been standing. No one ever got close. And this is exactly what we should be expecting. The longer we have a discipline, the longer we observe, the less records we should be expecting. They should become rarer. And if they're broken, the margin by which they are broken is expected to be smaller. But because climate is changing, it's non-stationary, it behaves different. It behaves like an athlete on steroids. And I want to illustrate this with this example. It comes from a climate model where we try to make this point and get it across. So what you see here is a climate model realization for the last 170 years. It shows you annual 7-day maximum temperature averaged over central US. This is an area where also in the observation, unlike Europe, there hasn't been much of a trend in heat wave intensity. So if you look at this simulation and you would only look into the past, you would probably come up with an estimate of a 1 in 1,000 year event that looks like this dashed line. But I'm going to show you what happens in this specific realization. There's a record-shattering event occurring a little later. In the real world, this event is not going to occur exactly in this particular year, not exactly over central US. But what we try to make the point here is that because climate is currently changing so rapidly, this is what we should be expecting to see in the coming decades, particularly in terms of heat wave intensities. Some of the places where we haven't seen trends suddenly records that break previous records by a very large margin. This is a climate model result, but we've also seen events like this over Siberia last year, 2003 European summer in Europe, or the so-called angry summer in Australia in 2019. You see in all these cases, previous records have been shattered by a large margin. I'm sure Freddie Otto and Rob are going to talk about attribution. And from the attribution research, we know that what used to be a 1 in 1,000-year event has already become a 100-year event today and may become a regular event into the future. So we have both. We have larger records, plus we have changing frequency. So we need to be clever and think of what we could be seeing what are the surprises we may see in the coming decades. There's different approaches. One that got a lot of attention in recent research is the storyline approach, where we think of rather complex events like the one I'm showing you here, which is a so-called compound event, where strong winds push a storm surge up the Adriatic. On top of this, due to the same low pressure system, we have a very intense precipitation event. And the two together cause a coastal flooding. So we need to take all our knowledge to combine these different factors, or maybe potential, or think of what would happen if the worst wind event would coincide with the worst precipitation event. And on top, it would happen to be a spring tide, and maybe in the future, even sea level rise contributes to this event. So I'm arguing what we need to do, and C3S is in a fantastic position to address this question, is to fill in the gaps in the observations with the reanalysis. They are so important and contribute also to process understanding, which is really key to develop these storylines. Then we have the ensemble prediction systems. Even without perfect predictive skill, they can inform us what could have happened. Even the near miss events, the one that didn't really unfold but were predicted, they could give us an idea on what we should potentially be expecting to see. And finally, climate modeling is moving in a way where we have larger ensembles and also higher resolution from the tendency to storm resolving model that could give us and inform us about what we should be expecting to see in the coming decades. So my conclusion is, let's get prepared for the extremes of the coming decades. Let's put together all our theoretical understanding, the evidence from observations, reanalysis, prediction, and projection, where C3S makes such a fantastic effort in providing access to all of these. And let's work together. It was already said yesterday, across the silos, scientists, stakeholders, we need to co-design storylines for potential extremes, surprises that we should be expecting to see in the coming decades. And I think C3S already does play and can play in a very important role, because it sits at the nexus between climate science, stakeholders, and society. Thank you.
Thank you. Thank you so much. That was a tremendous keynote. So helpful, beautifully delivered, and not too rushed. And I could have sat there for the rest of the day. Not that I don't want to hear from the rest of the speakers, but seriously, I mean, first of all, thank you for referring to climate as behaving like an athlete on steroids. So if anybody is tweeting, remember hashtag C3S21. That's a great one. An athlete on steroids was very, very helpful to your keynote. Fantastic. Also, just interesting what you said at the end there, because it reflected Francesca, who was in the second session yesterday. She was talking about exactly that. Can we not just sort of gather the data, or policymakers think in terms of just a flood or just precipitation, or just, we need to combine. You said, listen, we need to sort of take this storyline approach, and that can give us a better ability to predict even the near misses. So really, really interesting. And also those gaps that you identified, not least with paper and the need for digitization, which you said we're going to hear about today. I mean, given all of that, and you've said, you know, where C3S, you know, do a fabulous job, but things need to evolve. What else do you think we need? What one or two things do we need to measure or better predict these extremes? Anything else that you would offer there?
I think where there's a great potential is, first of all, I said all the access to all the observational data that does exist. I think this is really crucial. It's so important. And I'm a modeler, so I get basically I apply for funding for models, but I think even for us, and even if we go to high resolution, what we need is very good and very long observational records. And I think the second way we could push is that we go to larger ensembles projections also for the further future, where we get better samples, and this is so key for looking at extremes, better sample of probability of what we would expect to see in the coming decades.
Large and long. That's what we're
exactly.
focusing on. Okay, so somebody else can tweet that, but just sorry, I have to say this in the right context, obviously. There we go. Everybody wanted me to say that. I'm sure they're all chuckling, the speakers in Zoom. Well, not all of them, but some of them behind the scenes. So thank you so very much, Eric. Of course, I'm going to be asking you back at the end. So let's see if a question does come in for you, but I do already have a handful myself. But I do thank you very much for brilliantly setting up this first session of the day. You can have a breather for now. And I'm going to just give a little bit of preamble for our next of 5 speakers who are going to give slightly shorter individual presentations before I invite them all back at the end. The first of those additional 5 is Paola Mercogliano, who is Senior Researcher at CMCC Foundation, which is the Euro-Mediterranean Centre on Climate Change, and also Director of the Research Division, so Regional Model and Geohydrological Impacts. I hope that's enough of your bio. Oh, you've shared before I've asked. No, unshare. Sorry, so might forget. No, it's easier for our technical crew. Those are the instructions. Every other speaker waiting, please don't share yet. Welcome to you. It's lovely to see you. Don't be scared. It doesn't matter you shared. No one cares. There's always this going on at a digital event. It wouldn't be a digital event if we didn't have this. Am I correct in saying that you're going to share with us some key issues in the development of sectoral information systems to support disaster risk reduction? That's a sort of a tiny teaser. Would I be right there?
Yeah, right. I'm going to describe this new service that will be soon available on Copernicus Data Store about disaster risk reduction for extreme precipitation.
Thank you. And now I'm allowed to give you the
go
ahead to
Thank
share.
you.
Okay. Thank you so much, Paola. I'll just stick around to check that we can see your presentation. So ladies and gentlemen at home, bear with us while we have a fiddle. There we go. Okay. I will mute myself now, Paola. Go ahead.
Okay. Good afternoon, everybody. Thank you for introducing me. And okay, as I told before, I'm going to show the main features of this new service that will be soon available on Copernicus Data Store concerning the goal of the disaster risk reduction for extreme precipitation. The service, in terms of dataset and application, has been designed with the process of co-design with the users having a different interest in the world of disaster risk reduction issues. During this first phase of co-design, we identified and then we tried to address in our service 3 main gaps. The first one is the identification of the European areas more affected by heavy precipitation. The second gap is information, detailed information about the probability of occurrence and severity of extreme heavy precipitation event. And the third one, to define a framework for assessment of pluvial risk over urban areas. Okay, this is an overview of the data set and application that we have defined. I'm going to show now in details some general features of the application that we have defined. The first application give to the users the opportunity to explore ERA5 reanalysis and EOBS grid dataset across Europe by visualizing different administrative unit with different extension from NUTS 0 level to NUTS 2 level, to have information about the intensity, but also about the time evolution of different extreme precipitation indicators. To give you an example, it is possible, for example, to visualize the pattern of the days having daily precipitation higher than 20 millimeters, or the rainy days exceeding the 99th percentile of precipitation. And this is possible to explore over the period 1950 to 2019. Then with this application, it will be possible to have a clear overview of the area affected by heavy precipitation over Europe and also their characteristics. The second application, this is also for us very important, is a catalog collecting pictures of extreme precipitation event over Europe. Also in this case, it is possible to select the area, also in this case, different extension from NATS 0 level to NATS 2 level, and the period, the specific period, and then permit to have information about the magnitude of the event. Magnitude is related to the overcoming of the 95 or 99 percentile of precipitation compared with the climatology of this area, and then the percentage of the area that you have selected that was interested by this heavy precipitation. And then we also have included a ranking of the event. Ranking is based on these two parameters, the magnitude and the area. But also, I want to emphasize that with this catalog, it's possible not only to have information about the hazard, but also about the damages. In fact, thanks to the connection to external data set, you can also have information about the fatalities and the damages registered during the event. Then in this catalog, you don't have only the hazard, but also the damages is possible to show, to see. And then we have the third application. The third application is focused on European areas and more specifically on 20 different cities that you can see in my map. Here, thanks to the development of a new data set, a 2-kilometer reanalysis obtained by dynamically downscaling ERA 5, it was possible to define a synthetic indicator, the intensity, duration, of frequency curves, permitting a good characterization of the value of the intensity of extreme precipitation event at different return time period. This value is then adopted as input for a spill-fill simplified flood model. This permits to have the percentage of the flood area in the urban area selected, but also to visualize the area that has been interested by heavy precipitation. And finally, you can have also an estimation of the damages that you have registered, that you had for this typical event. Then also in this case, you have together the hazard and damages and impact. Okay, I think that it is important to highlight that thanks to this service, it will be possible to improve our current knowledge on the extreme precipitation event, but not only hazard, also information about impact and damages that can be useful for a very large number of users.
Thank you. You need to unshare if you can do that, and then I can pop back. Thank you so very much, Paola, and really, really interesting and interesting to see how you can make use of that new service. Thank you. I know you've just been able to scratch the surface. I have a quick question for you that's an important one for me, because I was recently doing some work with EU MODEX, so all around civil protection. So I'm going to focus my question on that. What do you think are the 2 or 3 emerging requirements for future climate data coming from civil protection users?
As explained before, in the first phase of our service, we had this long discussion with the end user. And then about the civil protection, their interest is mainly in the description of the extreme. They are interested to know about severity, area, and of course, they ask us to have very detailed information in terms of space and in terms of time. And I think that not only precipitation, of course, also, as you already mentioned, also wind, storm surge, and so on. And then I think that we need to improve also in the future our capability to represent the climate extreme, thanks to climate projection, for example, at very high resolution, such as the analysis that we have developed at 2 kilometers over the historical period. Perhaps this, I know that the community of climate modelers is working to have this. And I think also, for example, that the intensity duration frequency curve that I mentioned before can be useful in the future, because thanks to this information, for example, they can plan the adaptation action to have information about how to make the dimensioning of the maintenance of some infrastructure. And of course, this can help to mitigate the impact of the climate change.
Yeah. Thank you. Thank you very much for your very clear and comprehensive answer. Don't go away for too long. Don't disconnect. I am going to ask you back at the end, and I'm going to swiftly move on so that we hear from all our speakers before I pose some more questions. Thank you, Paola. You can put your feet up momentarily while I introduce our next speaker, who leads the environmental forecast team at ECMWF Forecast Department, where she is responsible for the daily operations and delivery of the European and global flood awareness systems and flood early warning components of the Copernicus Emergency Management Service. So can I please ask to join me, Christelle Prudhomme? That would be wonderful. Hello. You're there. I can only see myself thus far, but I can hear, there you are. It's very strange. I can see myself in the stream, but I can see you saying hello backstage in Zoom. And now here we are together. Tell me, what are you going to share in the next 5 minutes with our audience, please?
So I'm going to talk about the various challenges on forecasting floods. So kind of slightly different timescale than what we've heard before, but they're also associated with some challenges.
Okay, thank you. I don't imagine any of this doesn't have challenges. They also have challenges, Katrina. I think so. Okay, I'm going to let you share your screen so we can just check that we can.
Let's look if it works.
Yep, and then I will leave
Sharing
you
now.
It works. Perfect.
It works. Brilliant. So thank you very much, Katrina, and good afternoon, everybody. So let me first try to see if I can move my slide. Here you go. And Katrina mentioned it, you voted for it. We all know how devastating floods are. And when you think about globally, how frequent they are pretty much all the time. And that motivated the Copernicus Emergency Management Service to set up this European and global flood awareness system. We call them EFAS, GLOFAS. So they can provide information which is complementary to local understanding and forecastings. And this has been used, for example, by organizations such as the Red Cross, Red Centers, the Emergency Response Coordination Center. So now floods are complex, you know all that, and they've got sometimes very fast dynamics that also depend, of course, on the weather, but also on the landscape and the antecedent condition, which means whether it had rained yesterday or the last week or not. And higher resolution simulations can often help better reproduce the spatial and the temporal dynamics, and in particular, the flood peak magnitude and timing, as shown of the example on the left. But there is also another element that flood can impact several countries at the same time, and information from upstream area is essential to simulate the downstream flood waves. So that means that transboundary flood forecasting systems are really useful to produce consistent information across regions. But the problem is that they need to reproduce the varied hydroclimatic regimes, so that's another challenge. But if you think in practice, large-scale flood forecasting systems, when you build them, you need really to consider this trade-off between better science, increased spatial resolution, larger domain, and the associated data and computational costs. And that often drives also how the systems are designed. The second challenge, and Eric mentioned it, is first the understanding of the hydrological context and its variability. So one key element is the calibration of our hydrological models, which are used in general for doing the flood forecasting and to minimize the errors. And that relies on good quality observations. You're going to hear it several times, I'm sure. But Eric mentioned it, there are challenges to existing observational networks and then also the sharing policies. On the left, you can see the catchments where the EFAS calibration was last done. It's great, but it only covers 50% of the domain. And globally, that's even worse, the Swiss cheese, worse than the Swiss cheese. So an alternative is to use reanalysis, because actually when you've got a flood forecasting system, you need to understand this variability everywhere. And this is what helps, this reanalysis and running and simulating some hydrological series. So then you can define, for example, flood threshold against which to compare your forecasts. Third challenge, flood forecasting, is the uncertainty associated with forecasting of extremes. We've heard the ensemble approach for climate change impact. It's also very much the case for medium range forecasting, for example, where you use several scenarios and you can calculate the probability of an event happening. And the way we can show things is interactive maps with color markers and this ensemble forecast to help users looking at what's happening. But of course, users will also want to understand what the skill in the forecast. So globally, we can only do that with global statistics. And what we've done now is that, that doesn't answer the local questions of a very specific application. So we've generated the forecast of the path that we're using to estimate our own skill. We've made that available to users through the climate change, the C3S, CDS, so that they can do their own skill analysis. But the final thing that I wanted to say is that beyond flood event, some users really want to know to really quickly identify the areas with the largest expected impact that might require action, and not having to go through clicking all these dots we show as flood event. So by comparing the forecasted flood extent with the timing of the maximum flood wave and the exposure data, you can kind of color code and have risks, and then really quickly identify those areas which are worse off. So I don't want to take more time. These are the main points of my talk. Floods are complex. We've got a trade-off about data availability and complexity of the modeling. Reanalysis, hydrological reanalysis are really useful to fill the gaps. Ensemble forecasting is the way we've decided was the best way, and impact forecasting becomes more and more popular. Thank you very much.
Thank you. And if you can unshare, that would be fabulous. There's so many blooming things to think about, isn't there, at these virtual events? Again, really comprehensive. And I know that it's normally all of you experts are used to having far longer slots to speak, and we sort of forced you into this 5 minutes. So very, very useful. And absolutely, when you talk about the complexity and the value of ensemble forecasting, that's very clear. And I picked up there, you said the challenges to observing but also sharing. There's also those challenges, clearly. So, if we go back to the Copernicus Emergency Management Service, how can that data be used by C3S to develop like a catalogue of flooding extremes that might show possible trends in flood severity?
So I mentioned that we use hydrological reanalysis in order to understand the hydrological context and calculate flood thresholds. Those data sets, they can be used to do trend analysis as well. And now we've made them available through the CDS, pretty much real time for the global domain. So every day they're going to be updated, but they also go back to the 1980s. Then trend analysis can be done on those flood events.
Thank you. Would you, Christelle, go back to the 1980s if you could? I'm just asking you a funny question. I think I might actually, particularly for the music, but but thank you. And I really picked that up because that's something that we've talked about, and the importance of the real-time updates and that combination of the historical and what we spoke about yesterday, you know, C3S providing past, present and future very much within that whole framework. Thank you very much. I will be asking you back at the end for that brain box bingo moment, which is what I call it, but you can have a short breather in the meantime. Thank you. So I'm going to continue, ladies and gentlemen, and say I trust that you're still with us. You should be, because you've got absolutely fabulous people to listen to and learn from. Don't forget, if you have a question, post it, but you better keep it short. Please say to whom it's addressed. If we can't answer all the questions, we will do our very best to curate them and make sure that you get the answers you need, or put in touch with the speakers that you need to be put in touch with. But you can also do that through Swapcard. You should know that by now. We have three further speakers in this session. The first is a climate scientist in the National Centre for Atmospheric Science at the University of Reading. His name is Ed Hawkins, and I have the pleasure of asking him to join me on screen. Hello, Ed.
Good afternoon.
Afternoon to you. Now, did Eric correctly assign what you were going to touch upon in this issue of gaps? One of the gaps being stuff. Data is on paper, it's not digitized. So what are you going to focus on?
That's right. So I'm going to talk about the value of data and what we can learn if we manage to recover more data. We can learn very interesting things about extremes by going back further in time.
Okay. Thank you very much. I will just ask you to share your screen so we can just be sure it can be seen. Yes, there we go. And I can leave you to it. Thank you.
Thank you. So I'm going to focus, as I said, on the value of historical weather data. And I'm going to focus particularly for this presentation just on one single event in reasons of time, and that is on windstorms. So as Eric highlighted earlier on, the more data we have, the more we can learn about extremes. And by looking further back in time, we can try and ensure that the events that we've seen more recently, we want to add more samples to our understanding of past weather variations and make sure that we're not missing any events or missing any types of event. So I'm going to talk about a particular windstorm, one example to highlight these particular issues. And the one I'm going to talk about is the Ulysses storm of 1903. And so this is a slightly different storm to any one that we've seen recently. It followed a very different track, and it was a very, very intense storm, but it happened a long time ago. So what can we learn about this storm now? So we know quite a lot about this storm. The weather forecasters at the time were able to draw this hand-drawn with pen and paper synoptic chart on the left-hand side on the day of the storm, showing a very big low-pressure system over Scotland in the UK, bringing lots of very heavy winds across the UK and Ireland. And we also have some very old photographs from this event. We have a picture of a pier in northern England which got ripped to pieces by this very severe windstorm. And we also have pictures from Dublin in Ireland where thousands of trees were uprooted as the windstorm hit Ireland. And so this was very clearly a very damaging windstorm event. It's slightly different to anything we've seen recently, and we'd like to know more about it to learn what would happen today if that same storm or something similar happened today. What damage would it cause to feed into our understanding of windstorm risk? So we can go away and look at our modern estimates of what happened to this storm. So we have what's called a reanalysis. Many of our listeners will probably be more familiar with the modern reanalyses, like the ones produced by C3S, Era 5, for example, for the modern period. But we also have reanalyses going back much further in time, which cover this storm and much earlier in time. And so on the left-hand side, we have the hand-drawn synoptic chart from the Met Office on the day of the storm. And on the right-hand side, we have our estimate from this long reanalysis called the 20th century reanalysis for the exact same moment in time. And our reanalysis does not represent the storm as intensely as was drawn at the time. And it seems like the Met Office forecasters of the day with pen and paper were able to do a much better job of understanding the storm than we can today with our supercomputers and our modern weather forecast models. And that raises the question about why. Why can we not do a good job today as they could back 118 years ago with pen and paper? And the answer, of course, is data. And so the map now on the screen shows the pressure observations that went into our modern reanalysis to constrain the circulation and constrain the path and intensity of that storm. And there are just not many observations in our digital databases for this particular day or any other day in this period. And quite frankly, it's miraculous that the reanalysis can do such a good job with this sparse data network that we have available to us. There are very, very few observations over the UK and Ireland and France and Spain, for example, nothing over England and Wales, for example. But yet the people at the forecasters at the time were able to reproduce this storm quite accurately. So what's going on? Where is the data that was used at the time? And the answer is it is still in the original handwritten documents that are stored in dusty archives all over Europe. This particular example is from the UK. They kept the daily weather reports every single day, recording the observations that were transmitted by telegraph cable to London and handwritten on these daily weather reports. And so we spent some time over the last couple of years recovering the data that is on these handwritten pages and making them digital so that we can now use them. And so this is the page on the right-hand side from the day of the storm. And we've looked at thousands of pages like this and used volunteers to digitize by hand every single one of these observations of pressure, of rainfall, of temperature, to add it to our digital databases, which now means we have a much better sampling of the pattern and the pressure data that allows us to reconstruct this storm. So we can now do some experiments with our reanalysis. So on the left-hand side, we see the original reanalysis of this storm using the very sparse data network that was available a year or so ago. And on the right-hand side, we have the representation of this storm with all our new data added. So this is the added value of that data that we've spent time rescuing and recovering. And you can see the storm tracking over the UK and Ireland. And it's just visible by eye that on the right-hand side, when we add the new data, the storm becomes more intense, the wind strengths are stronger. This is a much better and much more credible representation of this windstorm. The example on the left-hand side, the winds are just not strong enough to cause the damage that we have the photographs demonstrating that occurred. Whereas the simulation on the right-hand side with the new data means that we have wind strengths that could have caused the damage that we have the photographs showing. And so we now have a credible representation of a very extreme windstorm that happened 118 years ago, thanks to our volunteers and the recovery of this data from paper. And so we can look at a footprint, the wind footprint of that particular storm. And again, by eye, you can just see the increase in the wind strength in our new simulations, showing the value of that data for improving our representation of this storm. And so I'll finish just by highlighting the fact that the job is not done. Again, this map shows the data that we had before in yellow, the data we've recovered in black, and the red dots show all of the other observations that we know exist. We have the images of these observations all over the UK and France and Italy and all over Europe. We know where they are, and they could be recovered and they could be added to our databases to further improve our representation of past weather and climate. And this goes for any other extreme event we can think of in the past as well. So in conclusion, I just think we need to get our hands dirty, dig into the archives and see what we can find. Thank you.
Thank you. Gosh, how absolutely fascinating. That is, what a great, that was fantastic. My goodness, and Christ, I hope you paid your volunteers well, highly, in alcohol or chocolate / other, because as you rightly said, that sounds absolutely painstaking. But
so yeah, thousands of volunteers, and they do it for free, and they do it happily because they recognise the value to science of what they do, and so we can demonstrate that very clearly now, and they recognise that, and they see the value in it and doing it.
Absolutely, but even just showing the last slide when you just put, and that's all the stuff that's not being recovered, and we need to get our hands dirty. I can absolutely see how they can see the value to science, and where you said there those words. Very, very different. You know, how is it so different to what we've seen recently? Oh, well, hang on a second. We were missing that data. That is staggering. A quick question for you, please. You know, if you have to crystallize that in a nutshell, so what do you say? What can we most learn when the best word is rescue historical weather observations? What can we learn about future extremes?
So, you know, we have now rescued data. We have rescued temperature data. We've rescued rainfall data. We've rescued pressure data with our weather rescue projects and our rainfall rescue projects that we've run. And so we can feed that data into the databases like Eric was talking about to understand the past. But I guess the really novel thing that we want to think about next, and we're doing the simulations now, is to try and represent some of these extreme events in a warmer world. And we can do that with experiments in the reanalysis to learn about how different these events would be now if they occurred today. And they would certainly be different. We might get more rain from the storms, we might get stronger winds, we'd certainly get more intense heat waves. And so we can use this data to try and learn about these very, very extreme events in the past, the most extreme we've seen in some cases, and how they would be different today and how much they would be worse today. And so we can learn a lot about what the risks are today from these extreme weather events.
That's absolutely fascinating. Thank you so very much. Don't go away, as I keep saying. Oh God, hang on, a quick question because it's come in. And while I'm talking, because I'm looking at the chat, Christelle, if you happen to be proficient, not now, so you've got time to look in the private chat, you'll see there's a question for you. So then at least we can crack on when it comes to bringing you all back together. Ed, how do you become a volunteer? Yes, quickly. How do you become a volunteer? I want to become a volunteer. Seriously, how do you do it?
So there are various projects around the world asking for volunteers at the moment. So ours is not running at the moment, but there is one called Climate History Australia, for example. So that is run by a project called the Zooniverse, which is the web platform that we all use to build these projects. And so the Climate History Australia is currently trying to recover data from Perth going back to the 1830s, I think, to extend the longest records they have for Australia, for example. And so adding all this data allows every part of the world to build on their knowledge of extreme events.
Okay, well, you know what, just without being too jokey here, I have an aunt and a cousin in Perth. So I think, you know, if I have some of the right qualities, I am going to put myself forward. I'm not sure whether I have the right qualifications, but absolutely fascinating. Thank you so much. You can take a short break because we have two final speakers before I bring everybody back together. Our penultimate speaker is a gentleman called Rob McSweeney, and he joined Carbon Brief, which is, of course, the UK-based website covering all the latest developments in climate science, in climate policy, in energy policy in 2014, and he became science editor in 2017. So there you are. So lovely to see you. Thank you. Oh, look, you've split the bookcase and the picture. You weren't sure what you wanted. You've done both. I applaud that choice, Rob. Tell us, please, what is the focus of your presentation?
Yeah, I'm just going to use my time to give a few insights into how extreme event attribution has been covered in the media.
Right. Thank you very much. So let's just see again, just test for you that you're all cool with your screen sharing. Before I disappear, there we go. Yes, that looks good. Okay, I can leave it to you.
Great, thank you very much. So I'm going to start with the first formal peer-reviewed study that linked an extreme weather event to human-caused climate change, which was published in 2004. And it concerned Europe's summer heat wave of the previous year. The paper aimed not to answer whether climate change had caused the heat wave, but whether it had increased the risk of its occurrence. And the researchers concluded that the risk had at least doubled because of climate change. So this study was widely picked up in the media. Here are some of the headlines. The research was something very new, and the media coverage reflected this novelty, with different papers taking different angles on the story. So, for example, the Times suggested that very hot summers are not necessarily a bad thing. So while it did report that thousands of people died in the heat, it also noted that many people enjoyed the hot weather. While over in the Daily Telegraph, it focused on how attribution research could be used as a basis for lawsuits on the back of extreme events.
Hang on, Rob, I'm sorry. Are you changing slides that we're not seeing change there, or perhaps forgive me for just stopping you there. I'm just checking because I can't see them change, but it could be me. Yeah.
Which ones are you seeing?
I'm just seeing your opening slide, but let me just ask the tech team to tell me in the chat if the audience is seeing other stuff. Forgive me, don't worry, I will make sure you have your time to present. Could you just it seems to be that I know you were having some issues backstage. It was just to let you know that we can't see what you're saying as you say it, as far as I can determine, which doesn't really help you, but I could.
Yeah, it doesn't.
But if it's no great shakes, maybe you want to have a fiddle while I know that there is an order of presentation, and it's not great if I bring our last speaker before you, but what do you think? Let me be guided by you.
It would, maybe we can try and sort mine out in the meantime while Freddie presents.
While Frederica comes forward, if she's ready. So if the technical crew is okay for that, you can stop sharing. And I know Freddie's there because I can see her ready to roll. So with your blessing, thank you. We can take Rob off and have a fiddle, the lovely technical crew. I can still see him. Maybe, yeah, he's not frozen because I can see his eyes move. If we can take him out of the live stream and just put me back and give Rob a chance to have a fiddle with his, there we go. So hold that thought, ladies and gentlemen, because I think it's important that you see what Rob is talking about, and we'll do our very best to fix that. So switching into his place is Frederica Otto. Freddie, as I've taken to calling her because she seems to be absolutely fine with that. She's nodding hello, who is Associate Director of the Environmental Change Institute at the University of Oxford, and she's also Associate Professor in the Global Climate Science Programme. So thank you for stepping up. I know you're going to share with us some lessons learned from, I think, 30 rapid attribution studies and link it a little bit to what you've heard from your fellow speakers. Is that more or less correct, Freddie?
Yes, and I think the 30 you've got from Twitter, because we published a paper recently about the lessons learned for 30 event attribution studies. I think what I will present are actually more, because we also have done non-published rapid studies. But yeah, basically what I'll be doing is bring everything together.
Perfect. All right.
In 5 minutes.
Let's see if you, it's always that emoticon first. Yep, it is always a challenge. Let's see how you do with your slides and see if they go smoothly. And I can see to the technical team, Rob is saying to you, if you can help him, he'd be very grateful. Right, there we go. Freddie, the floor is yours.
Okay, yeah, so thank you. We have been doing attribution since, well, I've not been doing it since 2004, but people here in Oxford, and I've been doing it since 2012. And we've done many studies trying to answer the question, whether and to what extent did man-made climate change alter the likelihood and intensity of extreme weather events. And in principle, and I hope you can see my next slide now. Awesome. That is straightforward, because as Eric was saying earlier, we have observations of extreme events, and we can determine from these extreme events when we, especially the daily occurring events where we have very long records, we know when we observe an extreme event, is it a 1 in 100-year event, or is it a 1 in 1,000-year event, or how rare is this event? So when an extreme event occurs, we want to find out what kind of event is it, and then find out in the world we live in today, with where we already have 1.2 degrees of global warming, what is the likelihood of this event in the world today, and compare that with the likelihood of the event in the world that was at the beginning of the Industrial Revolution. And of course, we can't do this from observations alone, because they have all sorts of changes over time in them. Well, we need to use climate models that simulate possible weather in the world today and simulate possible weather in the world that might have been without climate change. And if we do that, we get two different distributions of this possible weather, as you can see here on this slide. And then we can just simply compare these two distributions and see if they are different. And in this completely exaggerated schematic, they are very different. You can attribute this difference to man-made climate change. So that's the theory, which is, as I said, very straightforward. And we now want to see, can we actually do this when people are asking the question of what's the role of climate change in an extreme event, which is usually not 1.5 years later when a scientific publication comes out, if you've done the study, but which is days or weeks after the event occurred. And in a project that's called World Weather Attribution, and more recently in a Copernicus project called C3S 62, we have tried to do exactly this, to attribute extreme weather events to man-made climate change while the world is listening. And what we found out over time is that the actual attribution step that I've just shown is really the most simple of them all. And that's the part that you can automate. But there's a lot more that you need to do in order to attribute an extreme event. And one thing that you have to do is you need to be able to, you need to actually have observations. And as Ed and Erich both have said, that is not a given, because there are lots of places in the world where we don't have observations. And so we don't know what's happening, and we don't know if there are any trends for which we then can find out what caused the trends. But when we do have observations, it's still not straightforward to know what aspect of these observations should we actually look at. And Paola has said that in the database that they are developing, they provide an estimate of what's happening in the weather, what damages occur, and what are the impacts. And it's from just looking at the weather data, you don't know which aspect of the weather causes the damages. Was it the one-day extreme rainfall, or was it actually a completely soggy season? And only if you know that, you can, you know what is the most useful thing to attribute, because people ask the question because damages occur, not because something looks nice or interesting on the weather forecast. And so finding this out is really non-trivial and completely determines the result. And then, of course, we have to look at models. Not all the models are able to simulate the events we're interested in. So we need to test them, and there's a lot of judgment, expert judgment that goes on, because there's not the one right way to do that. Then, once we have done that, the actual attribution step comes. But then the results look something like this, and not like the nice schematic that I've shown before, where on, and I don't want to go into the details here, but just on the left-hand side, we have extreme rainfall in Texas using different methods. And here, all the methods sort of line up. All the models, all the observations show we have roughly a doubling in the likelihood of the event occurring. So there it's really straightforward to come up with an overarching conclusion of the role of climate change. But in the case of the German heat wave on the right-hand side, we don't. All the models and the observations show very different changes. And there we only know climate change played a big role, but we can't quantify it. And
just giving you a signal, but go ahead. Yeah.
All of this we need to bring together in an attribution study while the world is watching within a few days, so that we can actually feed into the news reports and answer the questions that people have. This is possible, but it's not straightforward, and it requires a lot of humans and not just machines to do that. But C3S really is the best place to do that, because there we already have all the ingredients. They are just not linked up yet.
Okay.
And I will not explain this map, because that is based on a map that Rob is going to show in a minute. So I will close here.
Thank you so much. And it's there we go. It's too much to say in too short a time. I think they're going to bring you back in just a moment. It's always just a little bit of fiddling between all of us, but I'm going to have to ask you to be as concise as you possibly can, because I had a question, but something did come in, and I'm just going to give it to you now before the end, when we're all together. What are the advantages and disadvantages of identifying extreme events based on fixed patterns and on moving averages? As concisely as you can. Thank you.
I think the disadvantage is that it doesn't always characterize the actual damages and what these extremes mean to humans and to our societies. The advantage is that you can compare extremes around the world and studies around the world if you have fixed indices. Okay.
Thank you for that, and thank you for whoever sent that in. That's great. Before we invite Rob back, he's ready to roll. What are the challenges of not just analysing but communicating the possible influence of climate change on extreme weather events? And you know, within that context, how important are the rapid attribution studies?
I think the rapid attribution studies are very important because people now know that climate change is happening, and we know that extremes are changing. And so if the scientific community is not providing an evidence-based answer on what the role of climate change is, someone else will provide an answer that might then just be based on values. And so the more we can say, the better we can also shape what people know about the science.
Yeah. Yeah, very interesting. Thank you so much for that. Doubtless there will be more questions in that quick fire round at the end. And what I am going to say, ladies and gentlemen, and to our speakers, is that because we did start a couple of minutes late, and because we've had this little bit of technical faff, which is par for the course at events, I am going to take 5 minutes. I'm going to eat in a bit into that into that session, and we can start afterwards 5 minutes later, just so that we can have a chance to pose a few questions. So Rob, you've been tremendously patient. You're coming back. The importance of communicating correctly, which is what Freddie just said. And it's interesting to hear from you, if I may. I'm just going to step away and let you, good luck, fingers crossed, start your presentation again. Thank you. Let's just see. It's there.
We'll give it a try and see what happens.
Give it a go. Okay, we'll just stay on unmute. Try and go to your first slide there, and let's just check that. There we go. I can go away now. That seems to be working.
Okay, let's give this a try. So as I was saying, this was the first formal peer-reviewed study to link extreme weather, to link human-caused climate change to an extreme weather event. And then my following slide was going to go through some of the headlines that paper generated. Picking up, hopefully you can see these. And then I picked up on a couple of them. So there was the Times pointing out that many people enjoyed the hot weather, and the Daily Telegraph picking up around how such a study could be used as a basis for lawsuits on the back of extreme events. So since this point, there have been hundreds more attribution studies, and at Carbon Brief, we've mapped them all, which you can see here. So each icon on the map corresponds to an extreme event that's been the subject of an attribution study. Those in red are events where climate change was found to have made the extreme more likely or more severe. And you can see that the majority of the studies have focused on events in Western Europe, the US, East Asia, and Australia. There are comparatively few studies from Africa, South America, and the Middle East. So the growth of studies has been helped by the annual collection published by the Bulletin of the American Meteorological Society, which started in 2012 and involves scientists from all around the world. And also by the advent of rapid attribution studies 5 or 6 years ago. So I just missed Freddie's talk, so I'm going to try not to repeat what she said, because obviously That's her area of expertise. She knows far more about this than I do. But I just wanted to look at one event in particular, which is another heat wave in Europe, this time in 2019, and look at how that was covered in the media. So here are some headlines. This is 15 years on from that first attribution study. And this time around, the headlines suggest a pretty consistent message. And in this case, it's coming in the direct aftermath of the heat wave. So it's while the event is still very much in the minds of the general public. So where that first attribution study was published around 16 months after the event, here it's just a matter of days. So in theory, from a communications perspective, this can help the public make that connection between their experience of climate change and its causes and impacts. However, it's worth noting the types of images that were used to illustrate this particular study that went along with those headlines. And here are a few examples that focus on the fun of the summer sun rather than the serious impacts of heat on public health and infrastructure. And for more on this, I direct you to the work on climate visuals by Saffron O'Neill at the University of Exeter, and specifically this article she wrote for Carbon Brief a couple of years ago. And I just want to finish by briefly looking at the influence of attribution on public opinion around climate change. The evidence is still quite limited. I picked out a couple of recent studies here. The first one studied 15 communities in the US that have been hit by extreme weather between 2012 and 2015. The researchers conducted interviews and searched local newspaper letters and articles. And the findings suggest that although single events have limited impact on discussions of climate change, some communities may be more receptive, particularly if the event can be clearly attributed to climate change. And in this second study, published just last month, including Freddie Otto as one of the authors, researchers conducted focus groups as members of the UK public. So it too highlights the influence that attribution can have with the public. It contains lots of great quotes from these focus groups, and I recommend reading the whole paper, but I just thought I'd finish with this one. And it just shows how a specific number can be more attention grabbing than kind of generalized statements about the impacts of climate change. And I'm going to finish there.
That's super fascinating there. Thank you so very much. And I am sure that you will get people who will read that whole report there. An obvious question, I think, for you is public interest. You know, you're looking at the media. We know just cripes more than ever at the moment how much our opinions are shaped by the media. You crumbs, Rob, you have a very interesting job, by the way, just as an aside. But how is the public interest in the connection between extreme events and climate? If you had to say, Kat, you know, there's, you know, it's changed thus over this last period. How would you describe it, that change?
I'm not so sure on public interest per se, but in terms of media interest about how often these studies are in the papers, I think has changed a lot. And I think it reflects a more general shift in kind of national newspapers in particular, that there's a much larger quantity and a better quality of reporting around climate change over recent years. I mean, I think it's notable that this year, in the run-up to the COP26 talks in Glasgow, you've got a number of newspapers that are launching dedicated kind of green climate campaigns. Papers which in the past may have taken a more sceptical tone around climate change, such as The Sun and The Times and the Daily Express. So I think that the public are much more exposed to this information, to these scientific studies, because the reporting is that much better.
Yeah. Thank you very, very much. Okay, I'm going to use the time well. We have about 15 minutes, just a little bit less perhaps, and I'm going to ask our lovely technical crew behind the scenes, beavering away, to please put all of these great speakers on with me. There we go, you're there. And I think we do have, I think, quite a proportion of what had come in from the audience has actually been answered by you. But there are, we could put the two together, perhaps, in some final reflections. But I'd like to just ask, can anyone raise a hand? And it is a little bit, like I said, the brain box bingo. Who should be responsible for this collecting, this curating, this analysing data about extreme events? We've posed the questions in polls where the responsibility lies or mainly lies. Any thoughts on that, please, from any of you? Just raise your hands. You don't have to use the raise hand function. You're all thinking at the moment. Anybody want to pop in with that? Yeah, Ed, thank you.
Well, so C3S are doing a great job at building a big database of all of the weather observations, collecting them all in one place for the first time. And so I think that's immensely valuable to build a one-stop resource where anyone can access all the data openly and freely, but they rely on people making the data available to them. And as Eric highlighted earlier on, that's what we need, especially if we're going to think about places in the developing world to try and better inform the risks there. We need the data from those locations. We need data from all over the world, from every country, to fit into our reanalyses and our estimates of changing risk. And so that needs to happen.
Okay, thank you so much. I see Christelle there has something to add.
Thank
you.
I want to add to that is just sometimes there are a lot of background reasons, political reasons, not sharing, especially hydrology. It's kind of water is like gold. So maybe we could also looking at alternative ways of sharing data, not asking the observational time series. As scientists, of course, we want that because we want to train our models. But maybe we could ask statistics. We can ask aggregated variables that still would help us build our models, validate our models, calculate trends, but are not the exact data. So they don't contain the secret people won't think. And I think as scientists, we need also to think outside the box and about why people don't want to share observations.
That's interesting. Thank you. Eric, yeah, I saw you nodding there. I was going to come to you. We are in sync, Eric. Okay. Yes.
Yeah, I just wanted to add that I used to be quite naive about this. I just thought, just give us the data, but we need to accept that collecting the data and maintaining it costs a lot of money, right? So I think one of the options for governments is to say, okay, the weather services or whoever collected the data needs to sell it to the public and make some of this revenue. I would argue we need to try to convince people that there is so much added value if we have open access to all of this data. And I know it's a long way and there's different hurdles. I think there's a long way to go, and we need to, there are obstacles on that road, but I think we've seen also in other areas where we didn't expect it, for instance, publication, that there's a push for more open access to scientific publications. So I think we need to convince whoever funds this research or collecting data that there's a lot of added value in making it available to research and to as many people as possible.
It feels like, when you say that to me, it feels like an absolute no-brainer that it should be so open and accessible without those obstacles. You use the word obstacle. What's the one obstacle, Eric, that keeps you awake at night then? What's your biggest, if you could wave a wand? And
so, the obstacle of that it costs so much money. Basically we already know maintaining current observational system. All these, people at ECMWF know a lot more than me. Is so expensive, and it's also a lot less fancy to sell to funders that they should be funding collecting yet another data point rather than the fastest supercomputer that I'm typically using and I'm asking funding for. So I think it's from that perspective, we need to convince all together as a community, the people who are funding this research and these observational system that is so important to all of us.
Indeed, I think it's Ed's volunteers that should be taking over the world in this sense. And just to also talk, I just want to ask a question around attribution, climate attribution. It was so fascinating Freddie, that you know, how you said at the beginning, you know, in theory easy, and then actually this is how it's all put together, and the fact that you have to also observations, so many lacking, create models that also simulate the past without climate change, then look at the weather now, and absolutely fascinating. Is there anything to add to make climate attribution more actionable to ensure societal relevance?
I think one thing that that actually for me was the main outcome of the paper that Rob showed at the end is that when we communicate attribution, we actually always say that, well, it's not the hazard that makes a disaster, but it's vulnerability and exposure in combination with the hazard that leads to disaster and damages. But still, all that people hear is the number and nothing about the context. And I think that is a real challenge to disentangle not only the climate driver from this natural climate variability, but also to identify what are the social drivers of disasters, and so that we can put these really into context and identify where do we really need to focus to be more resilient to these disasters following extremes.
That's interesting. So when you talk about, you know, that there's the hazards, but there's also the vulnerability. So how well do we really understand future vulnerability? That can be for you or for anyone.
Well, a lot less well than the hazards, I would say. And that's also very different depending on where in the world you are. But I think what's also important is that the time scales on which, for example, the hazard of heat is changing is super rapid, but the time scale on which you can reduce vulnerability is just takes time, because you need better governance and so on. And so these different timescales are really not helping us to in terms of resilience.
Yeah, they just rub up wrongly in terms. Yeah, absolutely. They're not keeping pace with each other, and yet they go together. Thank you so much. Anyone can jump in. I had another question, but I just want to give a chance because I've heard from Freddie, Erich, Crystal. I haven't heard from Rob. There you go. You're splendid, gentlemen. You raised your hand. And then Paula, anything that you heard from your peers that you want to jump in on, or from the questions that I just posed, I will give you a moment in the spotlight too. Rob, thank you.
Yeah, I just was picking up on what Freddie said about that kind of number in attribution studies, and it reminded me of a line in your paper around how the one you just mentioned, that how all the participants in the focus groups were adamant that communication of the scientific uncertainty around that number was unnecessary and potentially even detrimental to understanding of the findings. And I thought that was fascinating, because in particularly Carbon Brief, and obviously in any form of communication around climate science, you're obsessed with making sure that you give that full uncertainty and you show the range in the results and all these different factors that you know, saying it's not just about one number, it is about the spread of the results. Yet it was really interesting to see that from the other perspective, from the people hearing them, that just muddies the water, and actually that single figure is the thing that they want to be able to kind of take away. Yeah,
absolutely. Yeah. That variability, that uncertainty, is how, and all of it, and which is what we had asked a couple of times in this, in terms of, and actually it was raised yesterday by Blaz, how do you package it up? And we're not just talking about the public's understanding, it's also the policymakers. Sometimes, you know, it's exactly what he said. We are doing a splendid job, but we need to perhaps think a little bit better about the streamlining or the kind of data or the way we present it. Otherwise, we might not get the adaptation funding of the right adaptation efforts in the right way. Paula, anything from you?
No, about the uncertainty, I can say that, for example, in our exercise about the urban areas, we decided to provide data not only using the new data set at 2 kilometers, but also comparing the data obtained with the other data and other analysis. This is in order to give to the users the opportunity to look at the uncertainty, because of course sometimes we have different results, but in some areas, in some cities, the results are very similar, and I think that this can be very important for people making planning, making adaptation, because sometimes we don't have a big uncertainty. The results are quite close. And I think that this need to be highlighted, because there are some processes about extreme where, of course, we need to improve our capability, but a lot is already available. And also there were a question about how we didn't decide to make our analysis at a very high resolution at NAT3 level. The problem is that, as you mentioned, we have hazard analysis. We don't have a problem to provide hazard analysis, but unfortunately we don't have damages registration to put in our catalog. And we really hope that the catalog that I showed before can push the other community, not climate community, but the user community, to give their support to this kind of information, to put together hazard and other information, because I think that this can really support the decision makers.
Thank you very much. I'm keeping my eye on the clock. There's 2 minutes, 2 or 3 minutes. There is another interesting question come in. You may have caught it. So if more than one of you probably does want to respond, keep it short. First of all, big thank you. The extreme events presented are all relevant, but they generally stem from a single climate parameter. What about extreme events that are a bit more complex? So sand and dust storms, forest fires. I mean, I know that this was touched upon by Eric, you know, in the beginning, also by Ed. So I don't know who might want to pop in or raise a hand. Anything to add there about Freddie? Yeah, thank you.
I think just to connect with what Paola was just saying, a lot of the damages are actually not caused by a single climate variable, but well, in forest fires we have fire indices, and we can then also do similar kind of studies as for single variables. But I think because most of the climate science really focuses on the hazard and so focuses on single variables, we don't actually are always aware which of the compounds affect or are the ones that cause the most damages. And so I think we really as a community need to learn backwards. So look at the damages and learn what are actually the real, the best ways to identify what we are vulnerable to, and then to provide climate projections on that. So we really need to connect these dots.
Thank you very much. And on Ed, and then if everybody, while Ed has his moment, if there is literally a one sentence that anyone else wants to say as an outro, if they could wave a magic wand, and what might it look like in terms of our preparation, our efforts towards climate extremes in the next 5 years? What would you hope for if we were all here 5 years from now? What would be the biggest change? Perhaps we could have that as an outro. But Ed, first of all, let me hear from you. Thank you.
So just on these sort of compound events, I think the point that Eric made in his presentation about storylines is going to be particularly important over the coming few years, about how we think about what factors come together to produce an event. And we can think about that rather than just relying directly perhaps on climate model output or whatever. We can think about, as Freddie said, linking the different hazards that come together to produce a particular set of damages that we know we're vulnerable to, and building a storyline about what would need to come together to cause that. I think that's going to be particularly important in the future.
Yeah, thank you. And thank you for picking that up, that whole issue you talked about, Eric, about potential extremes, and also the importance of knowing about near misses as well, which is what you raised in your presentation. Any last words, but really has to be short and sweet from anybody? What would make you happy if we sat here 5 years from now and we were discussing the approach, the data, the gaps, the perception by the public? What would make you happy, Rob?
I would say in short that if you think back of the map I showed, if we mapped all the attribution studies, I'd be really happy if we were able to fill in some of those gaps, those parts of the world where they're not getting those attribution studies. I think that would be great.
Okay, well, I might actually end it on there unless anyone has anything to say, because everybody was nodding with all huge degree of sagacity there in their different ways. So they were all in complete agreement with you. So I am going to park it there to not prevail upon our audience anymore or upon our your good selves. And it gives us the perfect segue in any case to our next session, which is, of course, the last of today on climate resilience and risk. So I cannot thank you enough for keeping things so short and for being with me throughout this time and for really synthesizing the contents of your considerable brains. I do not jest and I do not wish to flatter you without really meaning it in a heartfelt way. So thank you very, very much to all of you. You're allowed to take a break now. Likewise, our audience can take a break for half an hour, no more, please. You can do a variety of things. You can go and have meetings that you might have set up. You can just look at the poster session. You can connect with a participant or with a speaker. You can have a gin and tonic if that's your thing, or a quick jog round the local park. Whatever it is, please don't forget to come back here, because we do have our next 90-minute session and it's going to be a good one. So if you can join us at 16:30 CEST, and just one more pointer before I'm asking you to come back for the climate resilience session, in case you didn't, a heads up, in case you didn't catch it, there's a user workshop on C3S and the Copernicus Mirror program that takes place tomorrow morning. So if you really, really want to have a nice day stuffed with all of this content, 9:30 to 12:30 CEST in Italian. It should be with interpretation. I haven't got 100% yet, but you can ask that question. But you register via the C3S event page. And oh my God, I've just got somebody so quickly, Sam, saying, yes, there is interpretation for tomorrow. So that's it. Join us, 30 minutes time, climate resilience, don't be late. And in the meantime, tweet, hashtag C3S21, share your thoughts with the wider community, and I'll see you back here very, very shortly. Thanks for now.
We are living in a world where the climate is undoubtedly changing, and that means our knowledge of the past as a way to anticipate what the future will bring is a less suitable source of information than it used to be. Climate forecasts for the season ahead or for the coming few years are not quite the same as weather forecasts, where the starting point, the initial conditions, have a relevant role and where we aim to predict specific weather events. We can use a pinball game like this one here to represent how climate forecasts work. Each tiny ball can be, let's say, the temperature in November with warmer values over there and colder values here. So if we count all of them, we have an estimate of the more likely values around this range here, and we know that these values, warmer here or colder here, are much less likely. But in the longer time scales of interest to climate forecasts, we have other components of the Earth system, ocean, sea ice, land, that might push the whole system to a slightly different place. We have all these realizations, all these numbers that would allow us to give an estimate of the risk of having an unprecedented cold or a warm just slightly higher than what is expected. And this is the kind of data C3S can provide to predict what future climate risks are.
Hurricanes are powerful storms capable of huge amounts of destruction, but hurricanes in the North Atlantic are known to go through quiet periods such as the 1970s, which had relatively few hurricanes, a low total cyclone energy, known as the ACE index, and lower than average hurricane damage, but they can also have more active periods like we're seeing now. Being able to predict these multi-year periods of low or high hurricane activity will be of great benefit to specific sectors such as insurance, as well as society in general. As part of C3S, the Met Office have collaborated with the Willis Research Network to produce forecasts of average hurricane activity and associated financial losses over the US for the next 5 years. The forecasts are made using a multi-model ensemble using 4 state-of-the-art climate models, initialized with the current state of the climate to increase their ability to predict the next few years. Both the final hurricane forecasts plus the underlying data used to make the forecasts will be made publicly available through C3S.
Climate models include most components of the climate system and describe their evolution and their interactions using our best knowledge of this system. Climate projections are simulations performed of the evolution of the climate system under the influence of both natural and human factors. The human influence for the future is estimated from a range of plausible scenarios of socioeconomic change corresponding to different emissions of human factors like greenhouse gases. Climate projections are performed with many different models in a similar way as investment portfolios. In addition to this, each model performs the simulation several times to consider as many possible realizations of the internal climate variability that is compatible with a given level of anthropogenic emissions. Climate projections are performed in the context of the CIMIP and CORDEX international experiments, where tens of institutions perform the same simulations and make hundreds of simulations publicly available. CIMIP employs global climate models, while CORDEX uses regional climate models of higher resolution than the global ones. The CIMIP and CORDEX results are a key cornerstone of the Intergovernmental Panel on Climate Change reports. But climate projections are also used, for instance, by companies or by public administrations to develop assessments and plans. C3S has become in a very short time a key enabler for the use of climate projections. The easy availability of climate projections through the CDS in a seamless manner, along with a wide range of observations, is leading to new opportunities for many users vulnerable to anthropogenic climate change.
Since the launch of the TCFD, the Task Force on Climate-Related Financial Disclosures in 2017, the compulsory reporting of climate risk for financial actors has now gained broader adoption to the point of becoming mandatory in several countries for large corporations. However, precise guidance remains limited on both methods and data to support the assessment of forward-looking physical climate risk, and market actors are now asking for a standardization of the TCFD approach. In this demo project, we tackle the climate data issue by defining precise specifications aligned with TCFD recommendations in terms of hazards, emission scenarios, timeframes, or uncertainty evaluation. We then assembled a forward-looking global hazard dataset based on Copernicus Climate Change Service data. To achieve this, we took stock from technical reports and engaged with market actors to co-construct the specifications and test the usability of a first version of a TCFD-aligned hazard dataset that serves as a demonstrator that could now be extended and updated to support TCFD initiatives.
To better quantify the impacts of climate change, various indicators have been developed. For instance, the expert team on climate change detection and indices, ETCCDI, developed a set of 27 indices related to changes in precipitation and temperature. These include simple indicators, such as yearly maximum temperature and yearly total precipitation, but also more sophisticated ones that indicate the duration of warm spells or wet spells. Further, a comprehensive set of indicators has been developed to quantify the effects that environmental heat stress can have on human health. Such indicators can be used on multiple spatial scales, for local specific questions up to global general analysis. To promote and facilitate the application of these indicators by stakeholders, climate service centers, and other interested users, we calculated them for the most recent suite of global climate model simulations CMIP6 and make them available through the C3S Climate Data Store.
The new CMIP6 models are of great added value for the development of climate change indicators for coastal zones. In the next months, a new dataset will be ingested into the Climate Data Store. And using a global hydrodynamic model, we have produced projections for total water levels, storm surges, and tides. And we investigate the impact of climate change on those extremes. Compared to the current dataset that's available in the Climate Data Store, there are two main innovations. First, we've increased the spatial coverage from European to global. And second, we go from projections for a single CMIP5 model to a multi-model ensemble of high-resolution climate models from the CMIP6 generation. And this results in a much higher accuracy. And furthermore, we can quantify the uncertainties and agreements between models. Altogether, we believe that this new dataset allows for an improved assessment of coastal risk and that can support decision makers in coastal sectors to better plan for the future.
Reanalysis is a numerical procedure which combines observations and forecasts and uses modern state-of-the-art numerical models to produce consistent maps without gaps, which means consistent in time and space. And these are valid on locations where there are no observations at all, for instance. There are global and regional reanalysis. The global is covering the entire globe. The regional ones cover one specific region of interest. Regional reanalysis are enhancing the value of global reanalysis in several aspects. First, they are using more observations than the global ones, like surface observations. They are describing the surface characteristics much better than the global ones, like orography, vegetation, snow cover, or sea ice, for instance. And most importantly, they are using special regional models on higher horizontal resolution, like, for instance, the Arctic reanalysis for C3S, which has 2.5 kilometer resolution, or the European reanalysis, which has 5.5 kilometer resolution, as compared to the 31 kilometer of global RFI reanalysis of C3S. This makes possible to describe the local weather and climate in more details.
Climate change is upon us. We humans feel the impact, but do you know that actually all life forms on Earth are affected? Climatic changes disturb habitats and force the species that live in there to move or adapt. Those that cannot adapt are prone to extinction. So climate change threatens biodiversity, the rich variety of life on Earth, which is vital to our human well-being. We recently developed the C3S Global Biodiversity Service, which offers bioclimatic indicators. The service helps scientists, policymakers, and businesses to reduce global biodiversity loss now and in the future. Indicators that inform about sea ice concentration, wind speed, wind direction, for example, help to assess the impact and draft conservation plans for Baltic seals. They give birth on sea ice and may see their pups at risk of predators if they have to deliver on land. Other indicators about future aridity, for example, inform about which tree species are climate resilient to reforestate tropical land in Central Africa.
The Arctic is really being transformed by climate change. It is the part of our planet that has warmed most rapidly in recent decades. And this is having a dramatic impact on all components of the cryosphere: the sea ice, the snow cover, permafrost, the Greenland ice sheets. All these changes make the monitoring of the Arctic an essential part of the mission of the Copernicus Climate Change Service. One reason this is essential is that the Arctic plays a key role in our global climate system. what's happening in the Arctic has impacts well beyond the Arctic region itself. Another reason is that these large climate changes don't just affect the physical Arctic environment. They have ecological, social, economic, geopolitical implications as well. So if we want to plan for and adapt to a warmer world, we really need to know and understand precisely how the Arctic is changing. Through its climate data store, C3S provides a range of climate data sets that are freely accessible to everyone and can help achieve this goal.
Originally, the C3S included regional climate change information only for Europe, for the European domain. But now we are expanding that information, including worldwide information from 12 additional Cordex domains. So now users may have access to regional projections in Africa, in Asia, and in America, in all land regions to undertake impact studies. And this activity has provided support to international activities such as the IPCC, because the consolidated data set and also the documentation which has been gathered in this process is being used in the next assessment report in AR6, and in particular in the regional chapters, which are assessing regional climate change projections, regional climate change information for the next report. So that's a clear benefit of Copernicus, providing support to those international collaborations, and we must be happy of that.
Regional climate models can be run at higher resolution than global climate models. This means that they are better at representing land-sea contrasts, height of mountains, and important atmospheric processes such as low-pressure systems. The future is highly uncertain, and we don't know how large future emissions of greenhouse gases will be, and we also don't know exactly how the climate system will respond to these changes. Therefore, large ensembles of climate change projections are needed for assessing future climate change. C3S has contributed by doubling the number of high-resolution Eurocordex regional climate model projections for Europe, and by providing quality-controlled data from these simulations. C3S has also contributed to documenting the models and results from them. Benefits of these new high-resolution Eurocordex simulations include that they are better addressing user needs for regional to local scale climate information. In particular, these models are better at representing climate and weather extremes, such as those involving high-intensity precipitation.
Water is central to many aspects of our lives and societal functions. Access to clean and fresh water is central to our existence and to our life quality. But water is also needed for energy production and transportation, which makes the water sector cover a very broad range of users. Each user has different needs of climate information for planning and adapting to a changing climate. The operational service for the water sector provides access to climate information for inland water quantity and quality indicators. We provide operational hydrological seasonal forecasts as well as climate impact information for the 21st century. The information is available at different entry levels, with original data for download for the more technical user, and applications to explore the data for the more policy-oriented user looking for an overview.
Here we're showing how the data from C3S is used in a H2020 project Seclifirm for the benefit of energy users. In this particular case, it's seasonal forecast. The first step, a very critical step, is to work directly with the user to understand how the climate information is used in their particular case. And what we've done here in the first step is to build a decision tree. This is done for each of the 9 case studies we have. The second step is to try to extract as much information as possible from the seasonal forecast. It's not an easy task, particularly for European region, but we have had success in doing so. And we found that even if there is a little skill, it's better than no information at all. The third step is also very important because we need to now deliver the service that we've built. And we've shown that we can do it in several ways in the project. One of them is with this visual tool called Teal. And we are developing this for some of the case studies where we develop the service, which will eventually become operational. So just to recap, 3 key steps: the decision tree, working closely with the users; 2, find the skill as much as possible from seasonal forecast; and 3, build a climate service that delivers the information to the user.
At Lobelia Earth, we provide with climate impact analysis, such as drought estimation, the prediction of fires, extreme precipitation, storm surges. We are experts on Earth observation data, processing and analysis, and the fact that the C3S provides with very long time series of a wide diversity of historical observations, models, has allowed us to enhance our product portfolio, and we right now can provide with very precise, validated information that is used by the public and private sectors.
Forestry conditions are changing. Winters get shorter, snow depths vary, frozen soil is less abundant. A few difficult years have alerted the forestry industry in Finland to get better informed. Basically, the interest for local climate information and more precisely formulated weather forecasts has increased significantly. In the process, the potential for long seasonal forecasts has been raised, and the use cases for these become also clear. Combining static, high-resolution trafficability maps with bias-adjusted C3S seasonal forecasts, using the ERA5 land reanalysis to do so, is informing users both on very local climate conditions and a bit of predictability further into the future. Harvester seasons has revealed new opportunities to organize cutting for a much longer time ahead. It leads overall to improved efficiency, and this especially has been interesting the wood procurement for the former pulp, now bioeconomy big factories.
At Predictia, we are a spin-off company with over 10 years of experience in applying artificial intelligence and big data to climate and meteorological modeling. Thanks to C3S, we are able to access global sources of climatological and meteorological data and use this data to give our clients information at a local level that is actionable. We work with private companies such as Iberdrola and Metro Madrid, and we also work for public institutions worldwide like FAO. Thanks to C3S data, we are able to provide these entities with the meteorological alert predictions and also the climatological projections that they need for agricultural, insurance, and many other fields. In addition, thanks to C3S, we are able to develop climate services like ClimateJust, a web service where the user can obtain the climate projections that they need, tailored to their needs, and also actionable at a local level.
Agriculture in Kenya is very vulnerable to climate change.
Fortunately, there are many programs supporting farmers, but are the measures they are implementing actually climate smart? For that, you need to know how the climate is changing, and that's where our demo case comes in. To help farmers to adapt, we developed a set of C3S-based tools that allow users to generate crop-specific indicators. These indicators are tailored in terms of temporal and spatial resolution using the power of the Copernicus toolbox. To reach out to farmers, we work together with extension workers and county Met Office in the 2 counties of Kenya. A story map visualizes how the application can be used to generate easy-to-understand interactive maps and graphs. Using the tools, agricultural extension workers will now be able to make better informed decisions about adaptation. We continue building capacity with the local university and the Met Office on how to generate tailored results for different types of cropping. And we hope to extend the climate atlas to other regions in Kenya as well.
Marine spatial planning is the set of policy mechanisms that determine how marine space is shared by people and businesses from different sectors. Marine species and habitats have a natural capital that underpin the activities of many of these sectors. However, under climate change, marine habitats and species distributions are changing. This poses a widely recognized challenge for the delivery of effective and sustainable marine spatial planning. In the C3S Marine Coastal and Fisheries Project, we worked with stakeholders on the production of a set of climate impact indicators for European regional seas. These include predictions for physical variables such as ocean temperature and the location of ocean fronts, as well as biological variables, including fish abundances. The data were incorporated into the climate data store and made publicly accessible to end users. In the context of marine spatial planning, we also developed and applied a set of tools to help identify whether ecosystems underpinning different marine sectors are predicted to be sensitive to climate change and where they are predicted to be resilient. Together, the data and tools can assist with the development of adaptation strategies for marine spatial planning. One of the major benefits of this service is that marine policymakers now have free access to data, tools, and documentation that would otherwise be difficult to obtain and use.
Our project aims to develop tools founded on C3S datasets to facilitate risk assessment for habitat suitability and vector abundance, and to offer guidance for vector management. Using C3S climate and meteorological data at the most critical locations to perform reliable risk assessment will contribute to reducing the global burden of vector-borne disease. The vector demo case is provided as a service to scientific experts, decision and policymakers, as well as to the general public through identified citizen scientist initiatives. Already, more than 20 unique stakeholders and user communities from multiple countries are using the demo case and are providing feedback.
A warm welcome for perhaps the first time, or a warm welcome back to our virtual audience and to our next fabulous speakers. This is, of course, the second session of the second day of this epic event, which is the C3S Conference and General Assembly, organised by Copernicus Climate Change Service and with the support of co-host the Italian Copernicus National User Forum. My name is Katrina Sickle and I have the privilege of guiding us all through this fabulous smorgasbord of content and brains. And this afternoon, when we talk about climate resilience, will be no exception. May I just remind you all, the Twitter handle #C3S21. Please spread your enthusiasm abroad. And also, we had apparently a lot of questions for that first session this morning on climate extremes, not this morning, earlier this afternoon on climate extremes, and we're doing our best to connect the speakers with you so that you can have your questions answered. Now, what's our starting point for this 90-minute discussion on climate resilience? Well, awareness of the risks that climate change poses to society. Okay, I think we can probably agree the awareness is increasing, but the knowledge and the understanding of current climate risk exposure and future climate risk is still pretty much in its infancy. So our speakers are going to share their experience and their expertise. They're going to explore the role for C3S in providing data and services and solutions to improve resilience to future climate impacts. So don't forget, you can ask questions. You can ask general questions in the chat. You can also ask specific questions for our speakers. Please keep them super short and say to whom they're addressed, and we'll come to those after each speaker has presented. Don't forget, I also love to ask you to take part in polls. And I'd like to do that right now, just as an opener to frame these discussions. So if you can get ready, we do have a poll. Let's test that poll function again. There's a multiple choice. Should we provide information about fixed warning scenarios in addition to emission-based scenarios, for example, a 1.5, a 2, a 3 degree world above pre-industrial conditions? Is that a yes or is that a no? So just take a moment. If you've been with us previously, you know that there is always a slight time lag between Swapcard platform where you are and Zoom where I am with the 6 speakers who will shortly entertain you. So I'm just going to give it a few seconds while you take your time to answer that binary question. And when we have an answer, I'll know, because the technical team will kindly post that in the private chat so I don't have to faff around with my phone. Should we provide information about fixed warning scenarios in addition to emission-based scenarios, 1.5 to 3 degree world above pre-industrial conditions? So let's see if there's any answers on that. 100% yes, nobody says no. I would assume that my speakers, I'm looking at you backstage, are not surprised with that response. I'm just having a look at you all, nodding. No, you're all too nervous. Oh, you're all too nervous to even respond to me. Okay, so don't forget, ladies and gentlemen, 1 keynote, 5 additional speakers. Shall we find out who our keynote speaker is? That would be wonderful. If you can join me on screen, please. Sorry, we just had a change. We've gone 88% yes, 12% no. The information about fixed warming, not warning scenarios in addition to emissions-based scenarios. So there we go. We gave that a little bit of time and that shifted. Okay, so who am I asking to join me? Our keynote speaker is a gentleman called Tom Phillip. He's CEO at Maximum Information. Correct me if I'm wrong, Tom, when you join me. I'm just going to wait for you to be put across so that we can share a screen. Maximum Information provides climate decision makers and businesses with knowledge and with tools to implement some, well, you say simple, cost-effective solutions to what is the whopping challenge of our time, and to also identify and optimize responses to the climate risks and also the opportunities relevant to their specific business. And you are also a research associate at the Centre for Philosophy of Natural and Social Science at LSE. So there we go. What is your starting point? How are you going to frame this session, please, Tom?
So it's going to be a quick thought experiment, I think, to really help people think about constructing valuable scientific research and data that is meaningful to resilience.
Okay, thank you very much. So I'm going to give you, as you know, the possibility to share. I'm going to check that you can see what you're going to share, and then I can leave you in peace and mute myself and give you your time to to set this nice framework. There you go. Perfect.
All good.
Okay, thank you very much.
Wonderful, thanks, Kat. So thank you guys for joining. I'm lucky to have a very distinguished panel behind me. So it gives me the opportunity to step back from, I think, some very applied and I guess sector specific requests and ideas, and really sort of get at this question of the philosophy of climate resilience and what that means. I think that this whole question isn't unpicked enough. So I'm going to try in the next 10 minutes to really run through a very quick thought experiment that I hope will help guide people's thinking on this whole topic. And then I know we've got a very, as I said, distinguished panel who are going to go through some very explicit and precise applications of this type of thinking. So I just want to start really with just trying to lay out to date the success of C3S. And I think one of the biggest things for me that I've seen is just the value of the dialogue enabled by C3S and similar initiatives can't be overestimated. Effectively, I know that the sector that I was working in when this first came along in 2015 was insurance and risk management, catastrophe modeling. Trying to have a conversation about climate change in that world was very difficult at the time, but really the wheels are turning very rapidly. As of about 2017, that was about the time when people really started connecting to these endpoints and really realizing, oh, this does mean that it's going to have impacts. Oh, that does mean that it's having impacts today. And where we're at in the last 6 months is actually quite remarkable. And these are headlines for the last 6 months. So Bank of England restarting their climate biennial exploratory scenarios. These are climate change specific scenarios put out to every financial institution in the UK market, have to respond this summer. So people are working on this throughout the various risk industries at the moment. We see massive insurers and their reluctance and actually divestment from portfolios with global warming potential in them, and then the world's oldest reinsurance market also stepping back from coal in its first official climate change policy. Effectively, what I'm trying to put across here, and the point there, is that it feels like that question about raising awareness about the importance of climate change, it feels like we've won that battle. I'm sure there are still battles there to be won, but the largest part of all of these different sectors really realize that it's important to them and that they need to act upon the information. And I think that therefore needs this sort of shift in thinking from let's capacity build toward let's help steer the thinking and steer the research that's being done by those sectors. And that's what I'm trying to present today, lay out a thought experiment that will help people deconstruct that. The slides are going to be quite wordy, but it's sort of necessary, I think, to lay out the logic of this thought experiment. And I hope it allows you to digest as we go later in time. This will obviously be uploaded onto the website. But I'm going to rattle through this quite quickly so that I can leave it to the other speakers as well. But climate resilience, what does it mean? As I said, I believe that deconstruction of that term is necessary to shape meaningful research and to develop solutions. So for today's thought experiment, I'm going to limit that to resilience today means ability to limit loss of human life from weather and climate events. I just want to note that question about resilience and risk, they're often interchangeable by people, but really there's different sectors that deal with resilience and risk differently. I really think that the difference between resilience here and risk is that if you were defining this in terms of risk, it would be quantifying loss of human life from weather and climate events. But one of the really important things, and this is an aside and an opportunity, I think, for C3S, is that does resilience mean that it's just effectively resilience is the inverse of risk? Is it that simple? Probably isn't. There's probably lots of complicating factors, but what I have seen in my experience working between those different sectors in the last 7 or 8 years has been that they often have different languages, have different terms for actually what are the same types of concepts, and just being a hub that I hope C3S can be to help translate those things will lead to resilience in itself, because there'll be this huge amount of body of information coming from lots of different sectors all at once. So that aside, whether that resilience is the inverse of risk, whether that holds quite so exactly, I'm arguing here that risk and by extension resilience can be expressed as something that catastrophe modeling uses and the risk industry, catastrophe risk industry uses to quantify risk. And it's this function, it's basically the interplay. So risk can be represented by a function of hazard, exposure and vulnerability and how those three components interplay between each other. And just for background, if nobody has seen this before, by hazard, in this instance, we're talking about atmospheric perils. So this can just mean effectively your hazard events. So hurricanes, floods, droughts, or other types of atmospheric perils. Exposure is population, asset values, and vulnerability is the damageability of the exposure to a given intensity of the hazard. And effectively, that's what we quantify in catastrophe risk and risk modeling in the insurance industry. That's how we'd quantify risk. And I think you can argue that resilience is an extension of that. It has a very, very important complicating factor that's often implicit and not talked about, but resilience talks to both the present and the future, I think, and it's often not really explicit what that timeline is. And so I'm going to simplify it here, and let's just, for argument's sake, say the future is out to 2100. So resilience is from now to 2100. So really, to unpick the resilience or risk question fully, we need to think about temporal trends, not just the static hazard, exposure, vulnerability. So if we just start thinking through that, hazard, the sort of trends through time are going to be peril dependent. Again, for simplicity, I'm going to argue here that on average, they're just increasing across the world. But we know that quantifying that in the present, uncertainty is high and it grows with time as we move to unfamiliar climate states. Exposure, if we're just looking at human life here, so with population purely, we know it's increasing. Latest thing that I've seen is around about between 7.5 and 8 billion. Well constrained in the present, but obviously that grows through time. Very difficult to know how society progresses and changes to know where what societal population will be. Vulnerability, another opportunity for C3S, actually, something that is talked about in some communities, isn't talked about enough, how their hazard and exposure interplay between themselves. And bringing that type of information, societal, socioeconomic information in here is definitely a very, very important and very under-researched area. Then there's a final complicating factor to this, the future value aspect, and it's a very difficult factor. It's one that feels distasteful to talk about, but the value of human life in the present versus the future. One important factor is one future life worth more than one present life. I can't see why anybody would argue that it is, but the flip side of the question is different. Is one present life worth more than one future life? And my hypothesis there is yes. And the reason for that is this concept of future discounting. So future discounting is effectively just discounting the future for lots of different reasons. The main one here is just uncertainty. Uncertainty about the future means you should put more value on the areas that you know more about. Very difficult concept to get over when you're talking about life, but it's not new to climate audiences. Was talked about, debated by the Stern Review, and debated before that in the 90s and early climate literature as well. So I'm going to assume that that concept holds. But let's look at this and look at the global deaths from natural disasters 1900 to 2018, separate the present and the past a little bit. So in the present, what do we see? Those numbers look low across the board. This is just three types of perils: flood, extreme weather, which includes windstorms, tornadoes and the like, and then drought. They look low, but that's not low. 5,000 years, I would argue, 5,000 lives lost per year is not low. It just looks low compared to the rest of the y-axis there. But there's occasional large spikes that we see, and effectively in what we'd argue is very close to the present climate. So things like Cyclone Nargis in Myanmar causing 140,000 deaths in 2008. In the past, though, we see these huge spikes, greater than 1 million lives lost due to drought or flood, that we haven't seen since the 1960s. Very close to it, I suppose, in the 1980s. But if you're putting something through, a trend through that, you see how this is dropping off over the last century. And arguably, this is the vulnerability piece that is missing. Effectively, vulnerability is improving massively over those areas. And when we reflect on everything I've just presented, this thought experiment flows through very interestingly. Again, one caveat before I go through that flow chart is that I'm assuming these data are perfect. They probably aren't, but ignoring that, I'm arguing ultimately here that the present and future necessitate different thinking for truly valuable resilience analytics. So if decreased vulnerability is the main factor for rapidly increasing resilience or decreasing risk, depending on how you're looking at it, over the past century, if this vulnerability improvement is likely to continue, and I can't see an argument as to why you wouldn't think it wouldn't, given improvements in technology and improvements in intention and understanding of these things, if it more than offsets any deleterious impacts from both increasing exposure and worsening hazard, if uncertainty is large on the hazard and exposure in the future, but is well constrained in the present, at least relatively, and if future discounting as a philosophy hold, all of those things lead you to a place where it feels like there is very little value in treating the future as we do the present. So modeling the risk of something, so modeling the risk of slightly more intense hurricanes, and even if we're going extreme with some of those, so let's say 50% more intense, 100% more intense, it feels like those things are going to be spurious or irrelevant to society at those points in time. So there's a really important factor here that I think is really important for researchers and data providers. It effectively means that a single question, which is minimizing loss of life, requires two very different types of data, and it's dependent only on the time horizon. And the conclusion is driven by the potential value of types of climate resilience analytics at different points in time. And to be explicit about what I'm saying here, for present risk and resilience, we'd be directing research at quantifying and mitigating extreme weather shocks in the traditional risk as a function of hazard exposure vulnerability manner, and then trying to drive down that background annual loss of life. But the future risk resilient, with all of the uncertainty, with all the discounting potentially of future value of life, means that we should be looking towards those other things. You know, what's the probability of these extreme greater than 1 million lives lost type shocks recurring in history? And I think that's an important point that we haven't really got towards steering in society, helping people think through those outside of the box questions that are fundamentally why we are doing climate change research. We are not doing it to change hurricanes by 10, 20, 30%, which is what I feel will end up going toward if somebody doesn't grasp hold of this question. So effectively, it's the key is users require guidance, even if it's not immediately obvious. I realize I'm probably out of time, so I'm going to skip through this.
Don't worry, Tom, you can't see me, you can hear me. You can slow down a fraction. Let me just give you a couple of minutes, because I think it's very important what you're saying, and I don't want people to lose it. So take a breath, that's okay.
Thanks. Great. Okay. Good. Okay. So take a minute then to really polish this off. Then.
Yeah.
So I think that I'm arguing ultimately here that scientific objectivity in the climate resilience and risk space isn't ideal, and it's a pipe dream. It's impossible to construct maximally valuable real-world connected scientific data without explicit knowledge of the world it's applied to. Therefore, we can't expect to do anything in isolation. One of the wonderful things I have heard in the last few days from all the other sessions is this idea of collaboration, this idea of handshake. So it seems like everybody's on that page already, and that's not an argument.
Okay, you can slow down a tad. No worries. Go on. Seriously, don't worry. Slow down. Slow down a second. You're cool. If there were interpreters, they would be probably ready to shoot you off screen afterwards. I jest. Go ahead.
So effectively, what I'm saying is that we, while I think that the C3S data store is an absolutely monumental step forward, it's potentially prone to misuse and production of erroneous information. And I say this knowing that there are certain industries at the moment that are having to go through climate change analytics, climate change risk management, that effectively are doing things that are potentially spurious and potentially misguided. And I think I can give you two examples as to why that's the case. So effectively, if we take that traditional risk as a function of hazard exposure, vulnerability, resilience analytics, effectively we will likely end up in a situation where it feels like there isn't too much to worry about from future hazards alone. The reality being that the vulnerability improvements that we're seeing are going to greatly outweigh likely the changes in the hazards that we're seeing on that sort of the way that we quantify them at the moment, so the frequency intensity of things like windstorms, tornadoes. So if we do this properly, we'll see that the hazard isn't actually that important. And to me, it's a big worry, because it feels like it could lead to potential massive inaction in the climate adaptation and mitigation space. Why do we need to worry about the change in hazard if our improvements in vulnerability have outweighed it? And effectively, there's another side of it as well. It feels like we're missing bigger questions. So potentially driving misinformation toward investment in resilient solutions for locations that actually in reality may be less in need than others. So that leads me to two key challenges, Kat. I'll just leave it at that. So effectively, how can C3S disseminate appropriate use guidance for real-world applications? I don't think it's enough for C3S to hear that this is a potential application, let's produce a static answer, and then that's it. People will pick up and use. I think C3S knows it has unique expertise and it needs to help understand those questions, particularly about the future, and iterate through. And that's ultimately what Challenge 2 is. How is it going to continually be able to iterate and going to walk hand in hand with its users to evolve its methods and produce maximally valuable scientific data? So I'll just leave it with that. There's a lot of stepping stones, I know, toward that point.
No, that's all right. You're good. It's so far. I mean, you will have lost quite a few people with speed, but no worries. You will not have lost everybody. And what's helpful is that I just wanted to give you the chance to come to the end of that thought experiment, that thinking. And of course, I hope if you can unshare your screen, you can make your presentation available for people.
Yes, it should be up on the website for sure.
Yeah. Okay. So just a quick one, Tom, for don't speed answer, just a short answer. And there's another question that's come in, but maybe we can hold that one. And those who are operating the questions in the chat can repost it for me to have a look at later, or for Tom to have a look at. But, you know, you talked there about the different sectors. Raising awareness is a battle that you think we've won or we've almost won. You were giving examples there with banks, with insurers. So if you had to specify the trade-off in the insurance sector between, let's say, the usability of data, I mean, the formats, the hazards covered, and the inherent quality of data, how would you?
So I mean, obviously, yeah, that's a difficult one not to talk rapidly through or to talk in depth about, but I think there's something missing in the question, right? And the word is value. So we talk about quality and we talk about usability, but if there's value in the data, it doesn't matter how usable it is, it will be used. People will find a way to use it. And I think one of the things that has been missed is this concept of how are we quantifying value data and the value of that data in the present and the future. It isn't something that's easy to do, but if we can start at least unpicking that question, and Richard, I know, has got examples that will talk to this. Should we use, for example, historical information to drive our probabilistic modeling about climate risk, or should we use, is it more valuable to use projections for that? Starting to unpick that is where we'll start getting real use of that data. But I think there's something missing in just looking at quality and usability.
Okay, thank you very much. And don't go away, because I am going to ask you back at the end. You can have a look at the question if you keep an eye on the chat between us in Zoom. So don't disconnect. Thank you so much to Tom Phillip at Maximum Information. Now I'm going to move on to our next speaker. And please, ladies and gentlemen, I know, and you would be right to think, hang on a second, I'm going to take extra minutes now because, God damn it, the keynote did. And I wish I could let you do that. But otherwise, we're going to end up frustrating the audience. So I've let the keynote frame it and given a bit more space there. So do forgive me, my other delightful 5 speakers. Next up is Jana Silman, who is Research Director at CICERO. CICERO is, of course, the Centre for International Climate Research, Oslo, and she leads the Climate Impacts Group. Welcome. An expert in the field of climate extremes and development of indicators for impact and risk assessment, and lead author of the 6th assessment report of the IPCC, amongst many other illustrious tasks and titles. So Jana, what's the focus of your 5-minute presentation, please?
Yes, hello. I would like to give an example from the finance sector on how risk and resilience is relevant in this sector and how C3S can potentially help.
Fantastic. Thank you so much for that. I'm going to just allow you to share your screen and check that we can see it. And then, yeah, that's a good start. We're good. I can pop off now and I can let you talk through this example from the finance sector. Thanks, Jana.
Yes, hello, and thank you. Yes, so I talk about climate risk and resilience in the finance sector. And I start with this map from the World Economic Forum, which shows perceived risks as surveyed through civil society, businesses, governments, and thought leaders. And on top, you clearly see changing climate is one of the top risks connected with extreme weather events. And also, of course, the infectious diseases are in this map. And as of 2021, infectious diseases climbed to the top risks by impact. But still, if you think about top risks by likelihood, the perceived risks are extreme weather and climate action failure. But what also this map shows is that we are living in a highly interconnected, globalized world. So we cannot stay, or we have to move beyond seeing single hazards or single risks, but we have to apply system thinking. And so for the finance sector, it is challenged with different types of risks related to climate change. It's on the one hand, physical risks due to the impacts of extreme weather, sea level rise, for instance. And there is the transition risk as society moves toward a low carbon economy, and liability risk due to legal responsibilities in climate change. And so these different risks translate in potential financial impacts that affect many different sectors and time and spatial scales. So, for instance, by supply chain disruptions, by changes in demands, or changes in resources. And these risks have to be navigated by the finance sectors, and they will affect investments they have to do in mitigation and adaptation. And the finance sector will have to balance basically investing in mitigation right now and thus facing a greater transition risk, or waiting with investing in mitigation and then facing more physical climate risk and having to invest more in adaptation. To support this decision making and underlie it with data, they need climate information. And that's what we try to do in the project called Clim Invest, which has recently ended, where we provided, we work closely with investors, and we try to identify what are their needs for climate information. And what became apparent very quickly in the discussion was that they are not readily able to tell us what they need. It was more a conversation and showing them what we have, mock-ups, like for instance, we show here on this website on climate information, to start a conversation, to raise awareness, to educate them about what climate information and associated uncertainties is available. And we showed it by showing a range of predefined indicators that are used in different sectors, for instance, and we accompanied that by showing examples and case studies how this climate information can be used and how climate impacts different sectors. And the investors were really keen and interested in this high resolution data and the information they got in the dialogues with us. So this is an opportunity for raising the awareness and bringing them more appetite for what climate information they need for their decision making. And so, but risk is not only hazards, as we heard from the previous speaker. It's about the complex interplay between hazards, the vulnerability and exposure of the assets that are relevant to the finance sector. And as I showed here, in the previous slide, we provided a lot of information on climate hazards, but it is more difficult in terms of vulnerability and exposure, because often this data is confidential and in the property of investors, they don't want to easily share it. So, so to close this gap of information on vulnerability and exposure and climate impact on the financial sector, in 2015, the Financial Stability Board, with the Task Force for Climate-Related Financial Disclosure, gave recommendations to streamline the disclosure of climate-related financial risks. And so to make that reporting a standard. And that also raised the awareness in the financial sector about the connection between climate risk and how it translates to financial risk. And what it, but this is the opportunity to move beyond hazard indicators to more risk relevant indicators. And that could be combined indicators, but there could be also data on vulnerability exposure that needs to be systematically collected, measured, monitored, and validated in order to provide a coherent picture. But also it needs to be rooted in the societal relevance, salient, it needs to be credible and legitimate. So what they often say in business, you cannot manage what you do not measure. And so for climate risk, this is no different. But so to finish, the finance sector really plays a big role with its climate smart investments in transitioning towards a low carbon society and climate resilient development. And for that, we need to integrate climate financial risk and into monitoring and sustainability into the portfolios of management. So monitoring, reporting as requested by the Task Force for Climate-Related Financial Disclosures. We need standards how to report, and we need also policies that promote the adoption of these standards and reporting. So that we come with a consistent environmental disclosure and more information to build resilience. And to close with Mike Carney's quote, who was the leader of the task force, better corporate reporting and better data analysis aided by the latest artificial intelligence trend of machine learning will help investors to tailor their investments in ways that help the planet. So, and also C3S can contribute to that endeavor. Thank you very much.
Thank you very, very much. And there's so much to say in this session, and I can see that. If you can unshare, Jana, I think that would help the, there we go. And then we brief it, there we go. And we've managed, thank you very much for that. And I pick up from what you said at the beginning, come on, there's no single risk. I mean, we're hearing this message again and again, this need for system thinking. And also, you know, as you said, it's very, very difficult. You know, we can look at hazards, but the vulnerability side, okay, hazards and exposure, but vulnerability, that's much more difficult. And for investors, much more complicated. And in fact, what was interesting to me is when you were giving examples there, you said, you know, they weren't actually able to tell us what they needed. You know, that's if I understood that correctly. So, you know, based upon that you said, why are climate indices useful for users, and how specifically that should they be produced and made available?
Yeah, so these indicators I mean, there are always some kind of aggregates of some information, but they help to give a broader picture. For instance, what is the hottest day of the year? Or we heard in the previous session on extreme events, there were different indicators to showcase what are the trends in the extreme events. And by starting a discussion on that and showing a map of drought indicators, and then starting the conversation, and then we kind of learn what are actually assets under risk. It's not actually drought that is important, it's probably precipitation, in what season, and what thresholds are important, for instance, for heat. And then you start this discussion, and by you have a building of mutual understanding, we can then tailor indicators to more the needs of the investor. So, but we need to start, and indicators are a powerful communications tool in that sense, and can start the discussion.
Okay. Thank you very much. And what I will say is, ladies and gentlemen, I can see that some of you have needed a tad more time to present. So, you know, if that impacts a little bit and I mean 6 minutes, please don't take more, then so be it. And hopefully if we get lots of questions in, you can also spend a little bit of time on swap card answering, because if you do the maths, we can't do everything. But I don't want you to feel okay, but please do stick to your time, but don't rush through. Thank you so much, Jana. Don't go away. I mean, momentarily go off screen, there we go, but don't disconnect, as I'll be calling you back. So who is our next speaker? Well, our next speaker is a physicist, Sandro Calmanti. Since 2008, and he'll come on as I'm giving a little bit of preamble. Sandro's work has focused on the creation of climate services and disaster risk management solutions for a variety of big organisations, the World Bank, UNWFP, and of course also various EU projects. He's a member of the coordination team of a project, MedGold, on turning climate-related information into added value for traditional Mediterranean grape, olive and durum wheat food systems. That is the longest title of any project, but it's really interesting. I think you're going to share with us the point of view from the agri-food sector, some of the challenges, the solutions, the lessons learned. Is that correct, Sandro?
Yes, exactly. Well, what I would like to share with everyone this afternoon, and maybe I can start sharing my screen. I have just a few slides to share. I don't know if I can do that already.
Yeah, you can share and then I'll probably disappear, so will you. But if you carry on talking, we'll hear you.
Yes, fantastic. Yes, Katrina, basically I would like to share with you some views about the perspective on climate resilience that we have gained from the point of view of the agri-food sector, sharing the experience we have done with the project MedGold. What we have learned during this project is that we have seen in practice that climate change implies a number of challenges for the sector specifically, from facing new unprecedented weather extremes, fight new kind of pests and diseases. Also optimizing unexpected cost is a challenge. But probably most importantly, what worries the industry in this sector is things like how to maintain, for example, the quality standard of products and how to meet the expectation of consumers that are waiting for their products, and also how to make investments, for example, how to renovate local supply chains. These are the most pressing questions. And I remember this sentence from one of our partners at the kickoff meeting of the project, which was back in 2017. He said, "We cannot make wine in the same way as our grandfather did." And I was very impressed by this.
Oh, hang on a second. Sorry, I beg your pardon for stopping you. Are you trying to move your slides as well?
No.
Ah, good. Okay, but you have started your presentation.
Yes.
Good, great, because I was wondering, I beg your pardon, if we were having the same issues.
No worry,
we had with
I just
Rob.
have 3 slides, so you will not see a lot of movement.
Perfect. Just checking, you have what you need. Okay.
What I was saying is,
a quote.
I was very impressed by this quote. No, we cannot make wine the same way as our grandfathers did. Because this came from an expert working in a company that produces wine since centuries. So not years, not decades, since centuries. So, and this told us that the industry is very well aware that they are facing risks that they were not used to, and that we are facing risks that we were not, that we have never faced in the recent past. So this is where we started with MedGold. Then MedGold was really a massive exercise of designing climate information services, which has engaged with growers in the 3 sectors that you had mentioned. We have engaged with the transformation industry. We have engaged with agromet and ICT service providers, with social scientists, with economists, agronomists, and also with a few climate experts, but just, at the end of the line. And the project, MedGold, has worked with the vision of putting decision-making processes at the center of the process of designing climate services, with an objective of really creating tailored and also potentially replicable prototypes of climate services, relying heavily on the data services that C3S makes available. And key outcome of the project is this dashboard, which from a certain point of view is just, yet another web application to show data, and there's, hundreds of them out there. So it's not new from this point of view. What is interesting in this, I think, is not the technology behind, but it's the process that has led to its implementation, which has taught a number of interesting lessons. And the first one, I think, is that data are not relevant for users. Of course, data are relevant, but not directly relevant. They need several stages of processing before they become actionable. And I think Jana was discussing this before, just before my presentation. So there is a long way from data to being actionable. Also, the concept of climate information, climate model reliability, as it is understood from climate expert, is most of the time useless for users, because climate experts, as myself, tend to overstate the importance of the quality of data, because it's the only thing that we think that we can control. Actually, the usability of data, which means the impact on decision, is far more important, and we need to take care of that. And also, and I think this is very important, stakeholders in the agri-food sector take a lot of strategic and tactical decisions on climate adaptation, even without any data, any climate data. And so there is a huge way to go in this direction to make data useful, although probably one important barrier in along this road is that the willingness to pay for this data and services exists only for large organization, so a bit higher in the value chain. With this in mind, I think that Medgold experience has demonstrated how climate service can actually promote resilience in the sector. First, by facilitating quantitative understanding of ongoing changes with, for example, access to quality historical data. Also, by supporting the optimal use of resources with giving access to seasonal outlooks. And also with long-term climate projections, climate services as a huge potential to support strategic investment, for example, research on the breeding of new crop varieties, and also on the creation of new local supply chains.
Okay, I need you to shortly round off, please. Just 6 or 7 minutes. Thank you.
I'm done with this, and this is where the main messages I would like to bring on the table. And so I'm just looking forward to participate to the follow-up discussion.
Okay, thank you. Thank you so much. I do have an immediate question before I turn to our next speaker. Now, you said there, I'm about to say you said there, you hadn't finished. You put key lessons and I interrupted you.
No, it's finished.
Okay.
It's just a summary of what I was saying before.
Okay, well, that's fine. You don't need to talk through that because it's beautifully it's beautifully laid out there, and I trust that that is available for our audience on both Swapcard and, as I said, on the C3S website. Because I do want to ask you an important question to something you raised there. You said, these users, the data isn't directly relevant because they need stages of processing to be actionable. Plus, by the way, ladies and gentlemen, decisions are taken by the sector, even the sectoral actors, even without data. You spoke there about the possibility of perhaps payment only being possible for the bigger players. So what needs, anything else? Just a couple of other things that need to change to make that climate data more actionable, more useful for them? Is it a money issue? What is it? Just very briefly.
No, it's not really a money issue.
You can unshare your screen. Sorry, I'm giving you a lot of throwing a lot of
Yeah.
things at you at the same time.
Yeah, I can.
Take your time.
Yeah.
Voila. So that was it. Is it a money issue or something else?
Well, it's not really a money issue, or not only. There is an issue of bringing the data close to the users, which implies a step of downscaling, refining the information, and bring them to a very local scale. This is very important because it makes the user more comfortable with the information that is provided.
Okay.
And then I just want to maybe repeat but support the message from Jana about the importance of using indicators as a powerful communication tool. So it's not the data, it's the indicator, and usually the process of designing indicators is a way of mutual learning with users, and it's a very interesting process.
Okay, thank you very much. And also you insisted there, you said, listen, it's not just about quality, it's about usability. And there you aligned it with saying it needs to be at local scale. And that resonates with something Tom said in his opening about, it's not just about quality, it's about value,
It's about value.
Interesting indeed, which is also in a sense what you're saying here. So I thank you very much. I'll ask you to come back at the end. Let me ask you, and let me ask all of our speakers who are sitting behind stage, those who have presented, do keep an eye on the chat. And if you can be ready with your answers, and also some answers to some of the things that you knew I might put to you, then that would be absolutely fabulous. We can ensure that we can cover a lot of ground in that Q&A session. So our next speaker is Head of Catastrophe. Oh, no, he's not. Hang on. Yes, he is. I beg your pardon. That's me doing a little bit of a switch around. Head of Catastrophes. That's where I stopped. The next speaker is Head of Catastrophes. Isn't that an awful way to introduce Richard Dixon? Our next speaker is Head of Catastrophe Research at the University of Reading. He's got lots and lots of experience, more than 2 decades in meteorological research, catastrophe or CAT, model building and model evaluation. So please give a warm welcome from behind your screens to Richard Dixon. And there he is. And can you let me know in a nutshell, Richard, what are you going to share with us this afternoon?
I think some of my friends could call me a head of catastrophe, actually. If
Do you think so?
Anyway,
would that be fair?
Yes.
Don't say that, because the picture behind you is going to come crashing down on your head in the middle of your presentation.
Yeah, so what I want to talk about today really comes out of a slightly a frustration of the reliance on historical data in the insurance industry, but also just an understanding that something that Eric Fisher mentioned earlier about historical data is great, but in insurance, we're always interested about the 1 in 100 year, 1 in 200 year event, which doesn't necessarily always show up in historical data. So I've been trying to look at ways to think around that.
Okay, thank you so much. So let's do that. Just check that you can share your slides, or are you doing that, or is a colleague behind the scene? No, you're doing that. Okay, perfect. Okie doke. Great. Thank you so much.
I will crack on. So as I mentioned, I can't seem to change slides. That's a good start. Oh, there we go. One of the things that I also wanted to talk about over and above historical data that I think a lot about generally is, has risk changed already? Often we're looking out to the future, 2050, and beyond. I think a message to CEOs and C-level people is that if you know that risk is changing already, then that's something we should be worrying about. I've already mentioned to you just now that when we're looking at these historical data sets that tend to inform the rates that we set in insurance pricing, they can't reveal trends in rare events. So if there is some sort of trend through climate change, it's very difficult to spot. So a lot of my work that I do, and I split my time between Inigo Insurance and a visiting research fellow position at Reading, is just trying to understand around historical data, looking at ways of bolstering it with other information to try and understand how risk might be changing. And I'll whiz through 2 examples to try and keep to time here. And hopefully it's nothing too groundbreaking, but it's kind of the way I like to think about it. And I would hope more people would think about this in our industry. So 2017, 2018, that was in 2020, 3 seasons where we had quite large wildfire losses. And obviously there's climate change in the background and there's exposure changes going on, but I wanted to get a sense for how things might be changing. So rather than looking at the wildfires themselves, I looked at wildfire potential. So this is a fire index distribution. It's a daily fire index distribution that was split from 1980 to 1999 and 2000 to 2019. And you can see here that there's a distribution of risk, and the higher the number, the more the fire index is, and the fire index is driven by things like temperature and wind speed, the dryness of the ground, etc. And you can see there's a 6% increase in the mean there between the two periods, but you look at it and think, well, nothing much is really going on there in the background. The thing is that above about 50, the index is defined as severe, and in my thinking, that's kind of the sort of numbers where the really big wildfires start to potentially occur. They can occur along all these different numbers, but these are the ones that have the really severe ones. And if you look at the change between the two periods in the green line here, you can see that broadly below the severe line, things are going up ever so slightly. As soon as you hit this severe category, things are going up quite dramatically. So it's seeing data like this in and around the actual wildfire loss data that makes me think, okay, there's exposure changes that are going on there, but we've got to be concerned here that there is something going on in the background, and this what is going on in the background is happening over a fairly short period of time. Again, coming back to the idea that risk is changing now and is changing potentially quite fast. That's one example. The other example is rather than just looking in and around the potential for things to happen, just looking at things if we'd had our time all over again. Now, I know Freddie Otto talked about counterfactual analysis earlier. I've done my own version of this. What we're showing here is converting this ERA 5 hazard for European windstorms that's on the C3S website and converting that to a loss. So we're talking about the hazard, the vulnerability, the exposure, we've all mentioned before now, converting it to a loss. And this shows that there is a decrease in losses over time in the last 25 years in European windstorm. And that decrease in loss has driven prices to drop in the reinsurance world. And my concern is that we only have one shot at history. So what if we had 25 shots at history instead of one? What does that look like? And again, I've done this exact same thing, again, using C3S data, but using forecasts of the forthcoming winter and converting that to a loss. So there's 25 forecasts per year. I've converted that to a loss, and this is the mean loss across every year. And you draw a line through it and it says, well, there's not particularly much of a change in loss. This is a fairly crude way of doing it, but this is my way of trying to understand, okay, are things really changing, and can we rely upon history and the trends in history when we only ever have one shot at history? And just to show another point here, this is the 1 in 10, this is the sort of the event you might have happen every 1 in 10 years, the sort of thing that we start to look at in reinsurance contracts. And again, the story is the same. It's pretty flat, it's wobbling around a little bit, but again, it's saying there's a flat change in the risk here, which is quite interesting when you compare it to what's happened in reality. So it's two ways here to try and look around, broaden our horizons around just relying on historical data. So I'm ending now, but this is my sort of quick summary. And again, I'm kind of repeating what a lot of people have said and that I've heard so far. So here's my two examples of hazard potential data and rerunning years multiple times, the two things that I've done. But of course, and as Tom has already mentioned and Tom has suggested, is how are we going to walk hand in hand with the user base to evolve our methods? And again, I'm just repeating what everyone else has said so far on here is the exposure and the vulnerability comes into this. And the one thing I'm really keen on is a common exposure and common vulnerability. If I could make a plea to the C3S guys to potentially host this data as well, and that behoves us in insurance to work with the C3S people to say, here's some good examples of exposure and vulnerability data to be able to get some answers out. And through those three things all added together, you start to see losses, and through that impacts, and obviously through that resilience. Have I taken less than 5 minutes?
Oh, sorry, you said that in the same tone. I thought you were still on your last slide. You can unshare. You're bang on. You're good. Thank you so much. I love that. That's the thing that's most important to you, not climate change, but did you deliver in 5 minutes? And with your very clear call there, let's see, because we've got a session tomorrow, the second session on how C3S and providers of climate data and climate data services do need to evolve So doubtless somebody's scribbling notes, and let's hear what your call and Tom's and how that comes into play, because the changes are so rapid from all quarters. Thank you. I like that. That's a great thing to tweet if anybody is. We only have one shot at history, but what if we had 20 shots of history? What does all that multiple simulations of history tell us? Because, you know, you said you're looking for the needle in a haystack in a way for those really rare stuff. So a quick question. I mean, you've kind of answered it towards the end, the kind of climate data that the insurance sector requires, and do you think there are any changes in policy that are likely to lead to actually new data requirements?
I think the changes in policy aren't necessarily the thing, it's just the changes in pressure from regulators to us. And with that comes a desire to, and again, I've chatted with Tom about this at length, offline, but the desire to boil down the uncertainty in the future down to a single number. The higher up the value chain you go in a company, the more people want to hear the number. And I'm quite keen, through the example that I've shown using this multiple cases of history, to be able to show actually in 25 years time or 50 years time or now, there's a range of uncertainty around how the number of hurricanes could change that are going to hit Florida. And that can change between -5 and +5. I'm just giving an example. If you boil that down to and take an average and the answer is 0, that's of no use to a decision maker. They need to be able to see the full range and not just a single number.
Yeah.
And that's what frustrates me, and I think should be something that we think about a lot more as we move forward into the future, as well as the uncertainty around exposure, how that's changing, and how we respond to events, and how vulnerability changes.
It's so fascinating, because obviously coming up again and again is this, there's this incredibly broad swathe of users, and it's not just meeting all their needs, but it's meeting their needs in the right way. And the right way isn't just timely, it's, because the decisions that are made are so dependent upon it. Absolutely fascinating. God, please tell me that you and Tom, Richard, talk about sort of random stuff like football and oh, I don't know, dog walking, and not just this. When you said, we have excessive conversations off screen about this, I'm thinking, please tell me that it's occasionally about rubbish, about superficial.
Definitely.
Okay.
Definitely.
Okay. All right. Thank you very much. You can step away briefly, because we've got two more fabulous speakers that I need to give a little bit of space to present. So who is our penultimate speaker? I need to get this right. I don't know why I'm having a little bit of a moment of strangeness here. Here we go. So our next speaker, he's there. He's going, it's me, Katrina. Is a research project officer at the EU JRC. He's currently involved in the development of the Disaster Risk Management Knowledge Centre Risk Data Hub. It's a web-based geographical information system for sharing data, for sharing tools, for sharing methodologies required for decision making. So obviously reinforcing that very powerful and important link between policy and practice. So Antofi Tiberiu Eugen, I hope I have not mispronounced your name too poorly or pronounced it too poorly.
No, it's perfect.
It's okay. No. So tell me, you're going to talk about this development? You're going to talk about the Risk Data Hub to us?
Yes, I'm going to talk about the Risk Data Hub and the way we are trying to manage relevant information. And what is management of relevant information provided through this presentation.
Okay,
so
all right.
I am putting the presentation on.
Perfect.
You can see it. Yes. So
I can't see it, but hang on a minute. That might just be me. Sorry. No, don't you worry. Take a moment. No. That's okay. No rush.
It's me. It's me.
Are you sure you're good at your job? Do we trust you to do your job, Antofi, with Risk Data Hub if you can't even share a screen on Zoom?
I'm okay.
So rude.
I'm okay.
Okay, I will shush now, and I will let you present. Thank you so much.
So I assume that you can see the screen right now. So I'm going to give this presentation on the Disaster Risk Management Risk Data Hub, which is, as it says in the title here, a template, a call for collaboration. So that says a lot from the beginning already. and how we are trying to build this platform in order to manage relevant information, both for climate change adaptation and disaster risk management or disaster risk reduction. So imagine that disaster risk related climate, it's coming in different, it's covering different, it's coming from different actions, it's covered by different actions. It's actually referring to preparedness, to mitigation, to prevention, to recovery. It's actually going across the scales. And we have to deal with all these variables in order to have a coherent, let's say, display of data and information, actually. So what we try to do in order to make it relevant and make it useful is to ensure a link from the between the global characteristic of policy and the local practice and implementation of this, local characteristic of implementation of this. And these two top-down and bottom-up actions, actually, they don't meet, actually. So we try to provide this link between those two characteristics, those two dimensional, let's say like this, through this platform. And how we do this, we try to get information from research communities, we try to get information on data, on methodologies, on tools. We try to get together CCA and disaster risk because they actually talk about the same things, but the same facet of the same coin, meaning vulnerabilities and meaning resilience. They are actually correlated. They just negatively correlated. let's say like this. And we try to say between these, let's treat them together and let's provide what is the most needed, which is the pinpoint to pinpoint exactly what are the risk drivers. And if we can do this and link it to the local scale, we can actually make data valuable and we can actually make the policy implementation accurate and worth considering. No? And these risk drivers, we already said so many times in the discussions, they are exposures, vulnerabilities, risk drivers that are let's say, immediately can be manageable. We can talk about mitigation, but those two are the ones that needs to be addressed, and those two are the ones that will make our data and information valuable. If we can accurately point to these risk drivers. And I'm going to go to the second slide. And recently, Risk Data Hub has been mentioned in EU strategy of adaptation to climate change as a platform where harmonized climate-related risk and loss data should be found, actually. And this is also reflects our development in the platform. We try to get the risk data, which means component, which means exposure, which means vulnerability, which means coping capacity, which means potential impact with the probability, which is the risk, on the same platform with disaster risk loss data, with disaster loss data, sorry. There is a link between those two. One is going to show us what is what could be lost in the future. One give us information what was lost, what has been lost in the past. What is this? Why are these important? Because if we can assess an impact through the risk assessment through models, it's perfect. But what we can do with the disaster loss data is to actually connect that intensity, that metric of the hazard with the potential impact, using past data. This is really important, as it can be also, as was many times mentioned in the presentation, a way of distinguishing the vulnerabilities. We also present data as I was saying, these modules, they have a cross all hazard approach. We have a cross sectors approach. We have a cross scale approach, and we have also, as I was saying, the dimensions. Okay, we also present on the platform outputs of research project. One of the examples is PESETA-4. So it only bring together scientific data that can be useful for the policy implementation, policy formulation. C3S partnership is important through data, through the let's say community, and through the support that can be used using the data, using the knowledge, using the methodology in order to efficiently support policy implementation. I'm stopping here. I'm sorry about the time.
That was me muted. That's okay. No, but I mean, had you come to your last slide, Tiberiu?
Yeah, I will just say one more thing.
Yeah.
What is important is to be able to link these two dimensions: the policy and the practice. The policy, the practice, the implementation. The policy that needs to have data on accurate, let's say, issues and accurate drivers of risk. This is something that these two components, they need to be connected.
Okay, thank you. And that's fine. And no worries. Anyway, it's great never to talk through a slide, particularly when it's as clear as this one is at the end. So if you unshare, I have a quick question, and don't worry, I will give enough time to our final speaker. I mean, probably possibly quite an obvious question, but what makes climate data, a climate data provision fit to be used by the European Commission? Could you just identify three, very briefly, three main points, perhaps?
Yes. So the European Commission, they need accurate data across sectors, no? That it's able to give information on, let's say, issues, on solutions of those issues, problematics, right? These issues across various actions, across various agreements, directives, they are potential impacts, right?
Mm-hmm.
What we are trying to do with the Risk Data Hub and what the policy DGs wants, they want scientific data. They want scientific-based information, so they can formulate policies on the robust, let's say, information. So that's one thing that they need.
Okay. And I'll give you one other thing they need. I'll give you. Yeah. Was there another what? I beg your pardon. Is there another key thing that you feel?
Yeah, there are several actually, but I was trying to get back to the disaster loss data, which is the evidence-based information that the policy DGs they need also.
Okay.
And also they need data on protection gap. So climate protection gap. What is not protected from the climate extremes and what it is protected. They need data on this one too. Okay. I was just trying to put pinpoint exact some examples, but all of these, and this is my final intervention, all of these, they have to be provided in the collaborative and on partnerships, because it's not possible without this.
Thank you very much. Thank you, Tiberiu. Don't go away for too long, because I'm going to ask you back momentarily. Should you have, everybody, can you please glance at that chat while our last speaker is entertaining us with his brilliance. And then at least we can launch straight into some answers to some questions. So our last speaker is head of civil bridge and ground engineering at one of the world's leading engineering consulting firms called WSP. But what's important perhaps for this session for you to know is he is a whiz in the development and implementation of design standards. So he's chairman of CEN TC 250, the committee with international responsibility for the standards for structural and geotechnical design across Europe, known as the Euro codes. And my goodness, can I just say, Steve, a very, very warm welcome to you. Steve Denton and Senelec and ETSI and all of these standardization bodies. They are Senelec particularly, I've moderated for a lot, and that's always incredibly testing for the brain. So I'm doing a bit of this here to you. And thank you so much for your patience. Why don't you tell us what you're going to focus on in this last 5-minute presentation round?
Sure, Ken. Look, thanks for that generous introduction. I am going to be talking about how we're looking to incorporate climate change into the development of the second generation of the Eurocodes. And although I did work on the development of Highways England's first climate change adaptation strategy about 13 years ago, today I'm speaking very much from the perspective of a structural engineer, right, and the perspective of the individual who is responsible for the evolution of the Eurocodes. And okay. Let me just check that that's working okay.
Yeah, we just take a moment. Yeah, that's looking good. Okay, thank you.
Fantastic. So what are the Eurocodes? The Eurocodes are the design standards that are used for structural and geotechnical design across Europe and also many other countries around the world. A few key stats. The European Commission estimated when they were first introduced that something over 500,000 engineers use these standards in Europe alone. They run to around 5,000 pages. They're agreed between 34 countries, and we've got a big body of experts working on the evolution of these standards. Many thousands of experts across Europe working on these standards, and we're at an interesting place right now. The first generation of the standards was introduced around 2010, and we're currently working on the second generation of those standards, and we're about 6 years into the program. And this is one of the largest standardization programs in European history. We have 76 project teams that have been working in 4 overlapping phases to develop content. And we're working to a timeline here where those project teams are getting to a point of concluding their work for those final phases 3 and 4. And then we move into the final steps of formal inquiries and votes of the national standardization bodies. And then we move into an implementation phase within countries that'll kick off around 2026. But what I wanted specifically to share with you today is the way in which we are looking at climate change implications and looking to build those into the Eurocodes. And it's helpful to understand the way these standards operate, that those 5,000 pages I talked about, the core content of the Eurocodes, they set out the requirements, the recommendations and advice that enable designers to design structures, buildings, bridges, geotechnical works, so they have adequate safety, serviceability, robustness, and durability. But there are a number of matters that are left open to national determination, and key amongst those are that geographically dependent parameters, such as environmental actions, are determined at a national level, and those are included in what are termed national annexes. So in the national annexes that accompany the Eurocodes, there are maps that contain characteristic values for snow loads, for winds, for thermal actions. And so what are we doing about climate change? At the moment, in countries across Europe, designs are based fundamentally on maps that use historic data. But we felt in developing the second generation of Eurocodes, that was not adequate. Obviously what are being designed, the structures that are being designed, are designed for a long life, and it was important that we provide the opportunity for countries to be able to build climate change considerations into the requirements they define for designers designing structures and geotechnical works in their countries. So what we have done in the proposed drafts, and these still need to go through the final stages of ratification, but what we've done is maintained the basis that the national annex contain those fundamental parameters. But importantly, we've also included the ability for a country to define scaling factors. Here, a scaling factor for wind, where minimum values of those scaling factors can be set in the national annexes, but also the opportunity for additional project-specific requirements to be added in. And it was interesting listening to Tom and listening to Richard, because I think that Tom may feel that this is dabbling a little bit at the periphery, although I kind of had some interesting observations on what Tom said. I agreed with a lot of it, but not 100% of it. And I think Richard may be looking at this thinking, that's the number, isn't it? Which I think you were objecting to, and maybe this feels like a rather superficial treatment. Then, of course, though, we haven't defined exactly here what those scaling factors might look like. And certainly, I'm anticipating that we will see geographic variation on those factors within countries. But one of the other interesting challenges is that when we design structures and foundations, we design them for different design lives. And so there's that interesting question that if you're designing something that's supposed to last 30 years, do you handle climate change in a different fashion than if you're designing something that's supposed to last 100 years? Also noteworthy that in terms of temperature, obviously a scaling factor can't be a multiplier, it needs to be a delta. So that we have built into the proposals as they stand. But what I'm very conscious of is that the development of those scaling factors is not straightforward. There is research in this area that looks at how you combine, if you like, the climate science, the statistics, and structural reliability considerations. But I'm also very conscious that the support of climate scientists, the collaboration between experts in structural reliability and experts in climate science is going to be vital to support countries in developing the national annexes that will then set the benchmark for the design of structures for the future. And Kat, that concludes my presentations. Thanks very much.
Thank you so much. That's fantastic. And you can unshare your screen momentarily. The first question to put you on the spot is, have you read those 5,000 pages?
Oh, I've read quite a few of them, yes.
Quite a few. I'm not sure that I take that answer. And just before I ask you another question, what did you not agree with? You said you agreed with a lot of what Tom said, but
well,
I can see him smiling now slyly back.
Yes, well, and of course, then we're going to come back to this open discussion, and then he can explain where I'm wrong here. But I think what I understood from Tom was that his point was that there is a risk that if we focus our considerations of climate change on, if you like, a kind of incremental treatment of our current approaches, recognizing that we've got a non-stationary climate, then we potentially miss the really big ticket items, those really big risks, resilience issues. And so we've got to be very careful to make sure that we don't miss those massive problematic issues. I think the point I took issue with was that it was presented as an or question, and I think it's an and question. I think it's an and question because, for me, it seems eminently sensible that if we're designing structures for 100 years, yes, we should be looking to take account of climate change. At the same time, I think we also need to be lifting our heads from the detail and worrying about what are those major changes that might happen. And just to give a little bit of an illustration of that, although what I've presented today is a focus on the characteristic values of climate actions, what we've also been thinking about is, actually, could there be something which changes? Could there be a change where the combination of extreme snow loads and extreme winds happen in a different fashion? And maybe that's the kind of very different scenario that we should be thinking about in the future. So, Kat, that's kind of a long answer to a simple question, but those were the points that I was picking up.
I think everybody's fed up with me saying, please, could you just answer this in 3.2 nanoseconds? Because these are clearly not, obviously, and that is evident to me, things that can be answered in 3.2 nanoseconds. Before I invite everybody back, so please get ready backstage, I'm going to bring you on for 10, 12 minutes. You talked there about, first of all, absolutely fascinating, because it's like stuff you must know because of climate change, because of disasters, because of extreme events, you know it, but you don't kind of think about it. You don't think about how that must all happen. So absolutely fascinating. And also what you said at the end there, designing structures for different lives, and having to think about all that. But when you're talking, you said there that, C3S, as I think I grasp, can offer valuable support perhaps for the national annexes. Is there anything else that you would say that would be useful for Eurocode that, that's not there for Eurocode, anything else?
Look, I think at an international level, I guess that that potential risk of combinations of extreme events happening simultaneously particularly those that affect structural design. So predominantly we're focused there on wind, temperature, and snow. That is something which we've explored and haven't found evidence to suggest there's a massive issue there in terms of potential changes, but that's an interesting area. But actually, you know, the business end here is mostly going to be at a national level in the development of national annexes, and I think it's nice to be able to put on the radar of climate scientists that that this is going to be an activity that will need to be done at a national level as we move into the transition of a second generation. So useful to be sort of penciling that in for you to your to-do list for a few years' time.
Okay, I love that. That's the typical British understatement. Pencil that whopper into your to-do list. Okay, so can I please invite my lovely speakers back? And there's a couple of questions that you will have already need to answer. And then there's a couple. So if you can all glance into the chat, but listen, it really, really has to be brain box bingo. So Tom, you're going to have to condense quite a lot into shorter. Let me give you the opportunity to come back on a question that was way, did you catch it? Way, I'd assumed you'd caught it way back. So
about the climate change has the potential to reverse historical trends in vulnerability. Yeah, sure. Do you want me to jump into that right now?
Yes, please. Yeah,
absolutely. So no, I think that's it's a good question, and I think that we're on the same page. I think underlying that point is that we have. I suppose the only place we're not on the same page is that there seems to be an implicit assumption that climate change does have the potential to reverse historical trends in vulnerability. And I guess what I'm saying is that we need to unpick that properly before we make those assumptions. And it is likely, I agree, that it will, but until we unpick it and quantify it, then at that point we can start to think about its impacts. And I think it just helps you frame, when you do unpick that, it just helps you frame the question more appropriately as to what you're trying to answer and really what resilience should mean to you.
Okay, thank you. Anything, did anybody else catch anything or want to comment on anything, catch anything on the chat or anything a peer said before I put these couple of questions to you? Or are we happy to dive into what's in the chat? Because there is a very, very clear question, and I put it to you beforehand, you know, that was actually taken from participants before this event. Is there among industry leaders an awareness about the risk for their business, the 1.5 degree world, the difference in a 2 degree, what can be done to increase that awareness? That's one thing. And also, you know, allied to that, is there specific action for the evolutions of standards and codes related to either safety resistance designs for buildings and infrastructures as estimated from GV estimates? So who hasn't spoken might like to, if you're having a think, otherwise I can come to Steve and ask immediately, because there is the evolution of standards.
Yeah,
I can come to you first.
Yeah, Kat, I'm very happy to just share some reflections on that. I think the you know, I think in terms of the evolution of standards, the question that really comes to mind for me in terms of climate change adaptation and dealing with resilience is whether fundamentally we have to adapt our assets or fundamentally we have to adapt what we do. And that seems like a kind of very simplistic question, but actually what we do at the moment is we maintain assets and we design assets so that they achieve an adequate level of safety. And that we do that considering all sorts of different factors. And climate change is one that we now need to build into that. And so for me, I think that the thing that I think about in terms of the evolution of standards is the way in which we need to incorporate climate change considerations into those decision-making processes and not deal with them as something which is very separate and distinct, because actually these are normally multi-criteria, complex optimizations, balancing all sorts of different facets. And this needs to be one further facet that we build into that decision-making. But I do think that when we think around that decision-making, you know, particularly in my world of civil structural engineering, in the construction sector, standards do play an absolutely fundamental role. The scale at which we operate means we never get to prototype. We design things and then they get built, and if it goes wrong, everyone gets to see what we've done wrong. And so what you need is a means by which you can verify things before you build them, and that's the role that design standards play. And that function means that they are exceptionally influential. And that means that they're a very powerful lever if we want to see change in the future. If we can incorporate that change within standards and the way in which we verify the decisions we take, then I think that can have a significant effect.
Okay. Thank you very much. Let's just, you know, we know this climate projection always comes with big uncertainties. How can you communicate? I mean, we're not just talking about communicate in the time, in the type of data, in the usability of the data, the value of the data, but regarding specifically the uncertainties and the possible mitigation strategies.
I have a comment on this. I can step in. And I mentioned during my discussion that sectoral experts are used to make a lot of decisions that are relevant in the climate domain without using climate data. And so this means that people are used to take decisions with maximum possible uncertainty in the world. And so starting from this, probably a possible way to communicate this is to communicate uncertainty in terms of reduced uncertainty with respect to having absolutely no knowledge about the future.
Mm-hmm.
And so from this perspective, you know, even the more uncertain climate projections can acquire a value, and transparent communication with users is always very much valuable.
Okay, thank you, Jana. I didn't mean to leapfrog over you there. My apologies. Thank you, Sandro. Jana, let me come to you. You need to. I'll give you time just to. There you go. You're unmuted. Thank you.
Thank you very much. I actually wanted to refer to the question on the difference between 1.5 world and the 2-degree world. What difference would it make? But I think I want to come back for answering that question to Tom's keynote speak, and I would like to challenge his hypothesis on this discounting for climate change. And basically, what he said, the argument is that we value present life more than future lives. But to put it bluntly, that would mean we value our lives more than our children's lives. And is that really how we can change the world or make us more resilient? Because this concept might be the reason why we have so low incentives to mitigate, to invest in mitigation. Because when you just look at the evidence in the last IPCC report on 1.5 degree, there we see how much it differs if we have a 1.5 degree world or a 2-degree world, because the impact of the extreme events will be significantly different in a 2-degree world towards a 1.5 degree world. And those people, when we reach 2 degrees in 20 or I don't know, when we reach that 20 years, 30 years, that will be our children mostly that are affected, that are now the newborns, will be 20, 30 years. They have to deal with the consequences. They have to pay for the damages. So I think we need to look in these data that we already have, talking about uncertainties. There is a clear information on what path we are heading if we don't stop emissions. So I think that should be incentive enough for investors to invest in mitigation, because the cost for adaptation will increase exponentially if we don't start in mitigating or investing in mitigation measures now. So I think I think we should rethink how we think about discounting and economic values, especially not only the value of data, but the value that people put in the future life and in loss of life, in their assets. It's not only the data that matters, it's what values the people, the society have in a healthy planet and a safe society.
Thank you. Thank you so much. Thank you for your eloquence. Thank you for your passion. I'm surprised you didn't try and push me off after Tom's speech and say, hang on a minute, I want to come in now. Or in fact, that you didn't say something before when you followed Tom. But before I just come back to that issue, and I think I'm aware, ladies and gentlemen, that it's pretty much bang on 6 o'clock. Just give us 5 more minutes to properly round this off without people sort of hyperventilating all of these lovely speakers before we sign off before tomorrow. So Tom, anything, and it really does need to be short, that you would like to say?
Yes, very quickly. I think we're on the same page, Janet. I think that I agree with you, and it does seem really inhuman to have that discount rate, right? But it's at the heart of any sort of climate socioeconomic modeling. But I agree with you, it's really difficult and it seems really awful. I think one of I guess the ultimate point that I'm putting on is that to really get at resilience for the future, we need to accept some of those things, as difficult as they are. I believe that modeling will be better for it, and our resilience in the future and our children in the future will be better for it if we are able to do that. Effectively, I guess I'm saying that in modeling in the present, if we have we know that it's much more certain than modeling in 2030 and 2040 and 2050, and that fundamentally means that we should put more value on the modeling, and then you end up having to unpick that. Does it mean we have to put more value on life? I appreciate it's really difficult. It's not something that sits well with me either, but I believe we will get more value out of the modeling and potentially more resilience if we allow ourselves to have that discussion at least.
Thank you. Last 2 sentences, Jana, and I am saying this with the absolute knowledge that this is something that you guys, plus everybody else, plus probably our entire audience, need to sit around a very, very large dinner table with quite a lot of alcohol in our hand and throw these ideas and opinions around. So I'll give you just 30 seconds, Jana, to come back, and I totally accept that we're scratching the surface. Yeah.
I just want to say, we don't have to accept this way of thinking. And as Albert Einstein said, if we want to change the system, we cannot use the same thoughts that have created the system. So don't let us accept these thoughts that have been in the literature, but change the system and change the thinking so we can build resilience, true resilience against climate change.
I will stop. Thank you. And doubtless you will want to engage in a conversation off stage and perhaps even with some of our audience. But again, time does not permit that. I haven't spoken to Richard or Tiberio. You haven't come back. So you're the last two really in these closing minutes. Anything that you want to again talk about, Richard, in terms of what you've heard that you didn't get a chance to say, and maybe even something important, just putting resilience with this program, which is a European program. We've talked about value of data, we've talked about quality, we've talked about usability and value being particularly important. Building resilience depends upon, Jana, as we're just having this conversation, how much we value a healthy planet, a healthy society. Anything else you could say about this particular program under the spotlight and how it can support that?
I think the one thing that jumps out at me that has come out from the questions actually is the idea of talking about uncertainty and trying to find ways of talking about it better. And I do think that using ensemble climate modeling, so simulating this year and the next year multiple times, is quite a good way to potentially at least get a vague grasp on the uncertainty as things are changing. It's quite an elegant way of being able to talk about that. So that's where something I'm keen to press on those that produce that type of output. I don't, it's down to other people to do that, but there is very willing users at the end of that.
Okay, thank you. So perhaps maybe Tiberio, the question also, because, go. I won't even ask a question. You want to say something? Go ahead. Go ahead.
No. I would relate to the uncertainty. I would just try to give a bit of a different angle on this uncertainty, because uncertainty it has to be communicated. If we talk about uncertainty in the preparedness of disaster risk, so in the land of the warning systems, let's say like this, from the examples that we had in the past, the first responders, actually, for them the uncertainty is not that important, because it's enough to know that something will happen there and they will rush there to intervene without not having any let's say image of the uncertainty. If we talk about the prevention, so the assessments on long-term, assessments of risk, which lead with in disaster risk management or climate change adaptation, yes, the uncertainty, it's really needed. It's really needed to being communicated, and is mostly related with the let's say impacts related with the monetary values, whilst the preparedness is impact related with the human lives. So that's maybe here the uncertainty. Let's say the different angles of the uncertainty depending on the moment you are looking at it.
Okay, any last second, but it's got to be a half a sentence, or are we good, ladies and gentlemen, for me to close, knowing full well that we're scratching the surface and that's what we're here for? Are we? Can I have your blessing to close now? And I think I've given you all the opportunity to speak, and I am sure that you will be asked by C3S to communicate with any speakers that might feel like, oh, I've got this burning question and I would love to be able to engage with you, but I cannot thank you enough. You do have the tougher slot at the end of the day following the first session, and you've all done an absolutely sterling job. Thank you again for taking the time and the trouble to share but a smidgen of the contents of your fabulous brains and experience. So I do really, really appreciate that. And I'm going to give you a reminder, ladies and gentlemen, that closes, well, you don't need a reminder that it closes the second day, a reminder that we do have a third day. And so a bit of important information, don't forget to really make use of the marketplace. Don't forget that you can book meetings for tomorrow morning. That's also important to know before we even all get together at 2:30 CEST. And don't forget that there is a session tomorrow that you can only register for via the C3S website, C3S and the Copernicus Mirror Program, 9:30 to 12:30 CEST tomorrow with interpretation. So that's Italian and English. Please, if you're leaving us, or even if you're not, please have the good grace to fill out a simple evaluation form. It's going to come to you in your inbox anyway, but then you can't complain the next time if you get an event that isn't shaped towards your needs and expectations. So that would be super, super helpful. Want to watch anything again? Don't forget, there are links on the C3S website and Swapcard until the 4th of June to the recordings of these sessions today and yesterday, and also you'll be able to get your hands on the speakers' presentations because there were some great ones. So thank you very, very much. Tomorrow, what are we looking at? We're looking at operational climate services, the opportunities offered by C3S operational climate components in different sorts of sectors and at different timescales. And then we're going to close with a forward-looking session. So we are celebrating achievements and milestones, but we have been speaking at this event about all sorts of new services. And we're going to close with a forward-looking session called Evolving Climate Services. Let's have a look at what we should think about going forwards in supporting a changing policy agenda and adapting the science and the technology landscape, and of course, critically, that really diverse user market. So hashtag C3S21, tweet to your heart's content. Don't be late tomorrow, 14:30 CEST. Thank you so much to all my speakers for having to listen to me finish off there. And I can wave goodbye to all of you and wish you all a very, very good evening. Thank you very much, ladies and gentlemen.